levels. Now, this architecture lacks something. It lacks residual connections. This is what ResNet comes with. Residual connection between blocks from the same either the encoder or the decoder. However, in the practice and even in their paper, these results are weaker than UNet, so we do not consider this in our paper either. We just mentioned it and did some preliminary tests, but it didn't perform well. Now, ResNet++, on the other hand, is the bigger brother of ResNet. It's the same as ResNet, a bit bigger, but and also introduces 3 exotic components: squeeze and excite blocks, heterospatial pyramidal pooling, and attention units. They are exotic, but however, as you can see on the last row, ResNet++ performs well in that case, which is cherry-picked. However, UNet and ResNet do not.
We'll continue by presenting some notable papers from the field. First of all, in Rails M19, the most comprehensive dataset consisting of images which depict bow, rail, and tram scenes was introduced. It can be used for semantic segmentation, our task, but also image classification and object detection. The authors applied full resolution residual networks for the task of semantic segmentation. Next, 3 approaches, different approaches sharing the same name will be shortly described. In the first one, ResNet 50 is used in order to extract features, and the feature map is rescaled back to the original image size end by end using a fully connected network. The second network, the second RailsNet novelty comes from the use of the information recognition module, which is able to exploit both vertical and horizontal features in the same time. The third and last RailNet enhances the result of the segmentation using the line fitting algorithm, which better maps the predictions to the real-world ground truth. Furthermore, they use stepwise separable convolution in order to reduce the computational cost. The last approach uses a UNet-like architecture, but swaps the classic encoder path with either a ResNet or a PGG backbone. We compare ourselves with the methods tested on Rails M19. In order to do this, we conducted a number of experiments using different configuration and different dataset splits. Furthermore, we tested our approach on dark images and on different dataset sizes using various augmentation. Here you can see some of our results. We used 2 widely used evaluation metrics, namely the die-score and the intersection over union. For the latter one, we also computed the values for each individual class. Another important mention is the fact that because in our problem there is a high imbalancement between the classes, we try to address that using weighted loss, denoted in the table by W5. In our case, it was the weighted binary cross entropy. This being said, we obtain our best results using the vanilla UNet using the normal binary cross entropy, but ResNet++ was able to achieve competitive results using only half the number of parameters. Here you can see some of our results. In the bottom row, there is the most simple case, and all networks perform pretty well. In the middle row, due to the presence of a bridge, there is weird lighting on some of the rails, which make them invisible for some models. Lastly, on the top row, we can see a more dense scenario, and even though from a distance they might seem similar, a UNet is able to achieve finer granularity. So individual rails are more distinguishable from further distance, which is an important thing. We wanted to create a robust model which works in all environments, so for that reason we tested on both day and night images. As expected, we found out that our model performs slightly worse on night images, and for this reason we use random brightness augmentation in order to simulate more night images from day one. This approach led to more than 1% increase in the rail IO in night images. Lastly, we experimented with the size of the dataset and some augmentation, and as in many machine learning and deep learning problems, our model became better and better with more data. What's more unexpected is the fact that using augmentation did not lead to a notable improvement in many cases.
Okay, now we prepare for your demo here, the demo video. This is on tram tracks from Budapest. With white you can see the rails and everything else is the video. Now, some interesting cases would be this car right here, which is an obstacle that intrudes the rail area. Our method also works in different weather conditions, be it snowy, foggy, rainy, or even at night, as you can see in this part of the video, right? It works very well at night, and there's also this interesting thing we should still work on right here. As you can see, between the main rails there is like this diagonal rail, which is not actually a rail. It's the shadow from the cable on the right. This is a limitation of our method. It thinks it's a rail. However, as you can see, there are not so many false positives far away from the rails, only close to the rails. When I say false positive, I mean pixels that are not rails, but they are classified as rails. We've also prepared for you some images with interesting cases. For cases, this one is during winter. As you can see, the method handles this case very well with a few false positives. Then this one is under a bridge where there is not so much light available. Now this is an even more extreme case with images at night, and one may notice that they are a bit more chaotic, not so granular, not so fine, and they are become more chaotic as at the further distance, at the rails that are further away from the camera. So this is another limitation of our method. And finally, this one was just interesting because it has these gray sun rays that are cast upon the rails and directly on the lens of the camera. Getting back to the presentation, we can conclude that we obtained some competitive results when comparing them to some other methods. We may also conclude that our methods are reliable for fast inferences since they are slimmer than the competition and use less parameters. To answer the second research question about how can we obtain better results in the competition, we used a lot Bayes normalization, which improves the training process, and also tried some augmentations. And as for future work, we believe that the research should be focused towards obtaining finer segmentation maps. That means having more detail, so we can detect the rails at further away distances and solve different problems, like switch detection or detecting whether there is an obstacle or a fault in the rail system. Moreover, the dataset we used had a lot of false positives and false negatives, so maybe that fixed that in the future. And finally, since this method would be used on videos, maybe it would be smart to try and use some sort of network that takes in consideration the previous frames, because each frame is dependent on the previous frame. If I detected the rail here, the next frame it won't be far apart, so maybe use some sort of network that can tackle that case. Here are some references for those interested in them, and we thank you for your time, for your patience, for your attention. If you have any questions, we're right here. Thank you.
Thank you, Alexander and Andrei. Any questions?
Yes, I have a question. Can you present again the slide where you compare your approach with other approaches?
This one.
Okay. Can you which one is your approach? Because I don't know.
I'm sorry. The first area are our approaches, and in the second areas are approaches mentioned in the related work segment.
Because otherwise we don't know. So you should not assume that we know everything that you know. So maybe in a different color your approach or some more bold face or something. And how can we see from this table that your approach is better? I see that in bold you have some values. So the larger that value, the better.
Yes, both intersection over union and chi-score are a measure of similarity, of overlap in our case. So the larger the value, the bigger the overlap.
And your method gives larger values.
Yes.
Okay. That's okay. This should be present in general in any research paper comparison. Looks like your approach for this scenario is better than others, which is an interesting result. Congratulations.
Thank you.
Yeah, nice work. So I wanted to make a remark regarding your demo. You were speaking about some errors due to the shadows that appear in the image. So towards the end of your demo, there was also a shadow, but it was not recognized as being a railway. Can you comment on? So this one is, and then you have another one at some point.
In the last picture that you presented.
Yeah, here.
This one?
Here.
Yeah, so can you comment a little bit in which situations it can go wrong, and do you have some hint about this, or you didn't know?
Yes, the one of the reason right here, if you remember the last shadow went something
Yes,
like this.
yeah.
This is a scenario we can find in real rails because switches exist where more rails merge, and it looks exactly like that.
Okay, but
Here,
this one
yes, here is
not
more
very-
horizontal. There is no example in our dataset which is like that. So this will never be considered as a real possibility for a rail.
Okay, that makes sense. And another question I had, how do you do the labeling, the annotation of the data?
Well, we have, as you can see, the same in this one. We have the first column, the input RGB image, and which we use grayscale, by the way, in the model. And the second column is the ground. So this was annotated by, it wasn't annotated by people entirely. Also, it was automated. So that's why there are some false, semi-automated, with some false positives and false negatives. And that's the annotation. It's either, it's a binary segmentation task. It's either 1 or 0, 1 for gray, 0 for paper. That's what it is.
Thank you.
Thank you. Thank you as well.
Okay. So next we have David Bogdan, and can you show the colleagues how to install SCSS?
No, trebuie să ne gândim la... Trebuie să dăm una... Trebuie să dăm una screenshot.
No, to the third party.
Și dăm una screenshot, nu? Trebuie să...
Very good. So first,
So, can I start? So, hi everybody, my name is Darius Sash, and together with my colleague David Bogdan, we will present our solution for employing knowledge graphs in the context of the problem of a resume ranking system. If we are talking about the context of the problem, one thing to mention is the fact that we are scoping down to the IT industry, so we will focus on hard skills for technical skills for people from the IT industry. And one motivation would be the fact that there is an increase in the labor market for the candidates and the personnel, and there is a need for a fast, objective, and automated tool that is capable of measuring some kind of or outputting some kind of measure of similarity between a job description and a resume. So we will aim to develop a system that is able to reason by using knowledge graphs and produce an accurate representation of the similarity between the job description and the resume. Now, jumping straight to the proposed solution, our solution is based on basically two independent and decoupled subcomponents, both being able on their own to produce some kind of measure of similarity between the job description and the resume, albeit a score or a similarity ratio. We'll see what that means later. So we have two subsystems, one NER-based subsystem. What does NER mean? NER means name entity recognition. This is a basic machine learning approach where we train a model to detect 6 custom labels related to the IT field. The labels, we will present them shortly, and one approach that goes further towards natural language understanding, where we convert the natural text into some representations and ultimately arrive at two graph representations, one for a job description and one for the resume, and we perform a similarity algorithm, graph similarity algorithm to measure the degree of similarity. Now I will let my colleague, we also have, besides these two components, we have an automated annotation tool component because we use machine learning, so we need to have training data. Basically, this annotation tool component is able to automatically generate annotated data from natural text, and this is by constructing a knowledge base from an online ontology, by performing ontology mapping, constructing its knowledge base and querying for each word if the knowledge base contains the word and labeling it accordingly. What's more, the annotation tool generates a knowledge graph that will be used to enhance the performance of our machine learning model. Now, the system architecture, as you can see here, we present the three modules. Here is the annotation tool module, the machine learning one, and the natural language processing or understanding module. We will try to explain the advantages of each models now by starting with the system of natural language understanding.
Yeah, so basically this component of the system takes the natural text of the resume and also this one. So the natural text of one resume, the job requirements text, converts them into an AMRL representation, then to a RDF representation, then to a Gremlin Tinkertoy representation, on which we perform a graph similarity algorithm, which basically gives us similarity score. More on this on the next slides. So, AMRL comes from abstract meaning representation. It's more like a semantic representation language, and its main objective is to extract the meaning from text. As we can see, there are 4 sentences which basically have the same structure, the same resulting structure. So, the boy may not go, the boy is not permitted to go, there is not permission for the boy to go, the boy does not have permission to go, are all transferred to the same representation, and also noted that these representations are dots, meaning dialectic acyclic graphs. So, an example which could appear in our context, to say, let's say someone mentions in his or her resume that I'm a software developer at Google and I have 3 years of experience in JavaScript. So basically, this text will be converted in this kind of a graph. We can see that inside the circles there are 2, let's say, terms. So there is a small letter, so to say, and then a slash, and let's say the word. That small letter represents an instance. So A is an instance of the word, and E is an instance of experience, L is an instance of language. Here, for example, when we have names, for example, for JavaScript and Google, this after mini representation tool happens to tag them as Google company and JavaScript as a language. Moving forward, the resource description framework, the RDF, this kind of tries to model the web ontology, so how the data is stored on the web, and we know a lot of relationships and so on. Has the triple resource property value. I know it's pretty hard to understand, but it is based on IRA, so something like an URL, so to say, which are different from each other, so they are unique. So, for example, this is a resource, a property, and a value. They are pretty hard to understand, and I think let's move on because we will have a more. So basically, from that we go to a graph. From here, for example, we can see here is the language. So here would be JavaScript, but its label is not shown in this picture. But we can see that here is an L, which is an instance of that language, and that L is an argument of experience. So if we remember, I said that I have experience in JavaScript, I don't know, for 2 years or something like that. And one argument of the word experience is language, L being an instance of that language, and the other is a temporal quantity. So I have the experience for X amount of years, which is then extract it into that abstracting representation has the power to extract this temporal quantity and also the unit in which it is measured, so in years. There we can see an I, which is basically an instance of the unit year, so to say. Moving forward, so we go through this representation, so to say, and at the final step, so to say, we do like a neighbors a graph similarity algorithm. So basically, to compare two graphs, these two graphs can be considered like knowledge graphs because they are not only terms in that, but also like instances. So the node E is an instance of experience, the node L is an instance of the node language, and so on. So we arrived at this representation, and from there we performed a graph similarity algorithm, which, as you can see, it is we went for a pretty basic approach. For more details, I mean, I won't bother you because we went through kind of a lot of other approaches, but we went for a simple one just to see that it works and how it performs. It is an iterative one, so basically we construct a similarity matrix. On the columns is, for example, the job description, and on the rows are the nodes for one resume. And at each iteration we update the value of each cell, and the algorithm is stopped when the difference between two steps, the maximum difference between two steps at each cell is lower than a threshold. I will perform a basic example of these two sentences. So requirements 2 years of experience in JavaScript, and the sentence 2, which could have been a candidate. I have 3 years of experience in JavaScript. Moving forward, so these are the representation of the sentences. I showed the node mapping, so to say, meaning that, for example, this year from sentence 1, which is the job description, is mapped to the node number 4, so to say, in the matrix. So this is the initial similarity matrix. At the first step, we just wanted to see the ratio between the in degree and out degree neighbors of each node, and we multiplied that by the equality of the labels. So if as we actually adapted that algorithm, as the initial algorithm didn't take care of labeled graphs, so we multiplied that with the equality of labels. So if the nodes have the same label in them, that similarity of in-out degree will, that average of in-out degree will be put, otherwise it will be 0. And then this is an initialization step, and then we have some update rules. So at each step k+1, we take the in similarity at step k+1 and the out similarity at k+1. That would be the old approach. I forgot to update this on the presentation, but we actually we added at those two, we added the equality of the labels. So here we did not multiply as for example, as we showed, like we can say that I studied computer science, or I have experience, or I study right now, or I finished computer science. And in those examples, finished and studied will not have the same label, and if we will multiply that equation with the equality of the labels, it will be 0. So in this case, we wanted just to add. So basically, we apart from this average, we added another equality and divided all by 3. So we maintain the property of the scores being between 0 and 1. And then, I have basically the in similarity of the nodes and out similarity of the nodes is given by the best matching between in neighbors of each of the nodes from the different graphs. And here is the termination condition. Moving on, I outputted the final matrix representation, and how we extracted the similarity score, so to say, from this matrix representation was a more best first match, meaning that, for example, from the first row we took that 0.97 and we marked that column as being taken. So when we process the second row, we don't take into consideration that column. So and so on. So we take the biggest value from each column, from each row, and then we basically make an average. I set that the similarity score of those two requirements at least 2 years of experience in JavaScript, and I had experience of 3 years in JavaScript was 81%, and along with the name entity component was 44.32 points, but not from 100 as my colleague will continue, and yeah, I think.
Conclusions, please. Let's move to conclusions.
Am scris, dar aplicăm pe jumătate, că mai era o componentă întreagă.
Nu e, da,
I'm sorry, I missed it. Please, the most important.
Alright. So, from the other approach, which is a basic machine learning approach, what we have brought as an improvement on a basic one is the fact that we use a knowledge graph that is constructed from.
Don't go into details.
Okay.
So you use the knowledge graph. Okay.
All right.
I understand this.
Okay, I will. I think it's self-explanatory if I give you a scenario. So let us consider a job description that proves the candidate.
No. I'm sorry, I have to interrupt. You are getting into more details now. Let's give an example. No, we don't have time. Your time is expiring. Please present the most important aspects, results, conclusions, strong points.
Okay, so let's.
Not details, not examples.
Okay. Talking about results for named entity recognition part, we have shown an example or a job description that says we need the seniority for all the candidates to be junior mid, we need them to be software developers, know languages such as Java, Scala, and technologies as Spring, Jenkins, and JUnit. And as you can see, for the labels, for different labels, these are the entities that were recognized with our entity recognition, aided by the knowledge graph. So we have OCA as a certification, software developer, object-oriented programming, Java and Scala, and these are the tools and frameworks. One thing to mention was that the Java instance was aided by the addition of the knowledge graph, inferring a relationship between object-oriented programming and Java, because, as you all know, Java is based on an object-oriented paradigm. This would be all, and talking about further improvements, enrich our dataset, explore new graph matching algorithms such as 8-star or others, and right now the transforming from natural text to Amaru and from Amaru to Rudufu is done by a tool, and enhancement would be to develop the transformation pipeline ourselves.
Okay.
Thank you for your.
Thank you for your presentation. Question, please. Anyone?
It's a very nice and complete work, I would say. We did a lot of work here. I was curious, do you see any future improvement regarding graph representation?
I mean, we didn't have an exact pipeline at the beginning. We didn't know that we will go from ANR to RTS to Gremlin and so on, and finally ending up with a graph, so to say. But yes, things can be improved there because, for example, when an instance is created from a workflow related experience, it gets like E, and then when another instance is created from, I don't know, another word which starts with E, it's also given a label as E. So yeah.
Do you have issues with time processing?
Yeah. But, I mean, the name entity recognition, if you go back one slide, on 32 resumes of approximately 30 words completed in 0.6 seconds, and the graph matching algorithm by itself on the same data completed on 564 seconds, so that's 10 minutes more or less. But the whole application completed in more than 2,500 seconds, which shows us that those intermediate tools that we use to transform our natural language to different representations take a lot of time. So yeah, that's why my colleague pointed out that we need to, in further work, we should take care of those transformations. And also, the graph matching algorithm would be improved. We just implemented one simple solution. Not that simple, but we updated the solution so that we see that it works and how it works, and from there we can go to other more complicated solutions.
Having used RTF, RTF is not really
That,
RTF, and then I didn't know in Cluj they call it beautiful. Having used the RTF, do you see any way to improve your approach, making use of the huge knowledge that resides on the
So initially we thought like that, but then we split it. So my colleague came with querying the DBpedia by using Sparkle. So we basically added more information in our system, but not in this component. So yeah, we kind of tackled that part, but we didn't combine them like 100%.
Basically, we use RDF to construct a knowledge base that is later queried to annotate our data and help aid our machine learning.
Yeah, and when you annotate data, then you make enormous use of other resources.
Yeah, exactly. We've combined, we use like 2 or 3 online ontologies, and it's completely automated. It doesn't require any human intervention besides the sentences in natural language.
Thank you.
Thank you.
Okay, so I also have some comments. So clearly you have the following challenge. You have worked a lot, and now you have a limited. But in the diploma thesis, you will have double the time because and I suggest that you present separate parts of your knowledge.
Yeah, we do.
But here the time was limited and the work is large. You insisted a lot on details like in this matrix, the value. No, this should be left to the readers only. Insist on strong points. So that's my advice for the next presentation. Thank you very much.
Okay, so the next speaker is also Andrei Daniel.
Andrei, please.
Okay, cool. So, wait a second, let me minimize this. So, my name is Barz Andrei, and today I'm going to present to you 2 new approaches for computing tuple importance in the context of load shaping for data streams. So, what is the problem that we're trying to solve? First, the amount of data that software developers have to deal with have increased tremendously in the last some decades. And also the interrogations that we have to deal with have increased in complexity with the increase of complexity of data, logically. And more data must be analyzed as it comes in a system to show relevant information about how a system is doing. This is most commonly seen in IoT applications, and it's growing into some other domains as well. So first, I would like to present a little bit the domain. We want to present what a database is. So first, It's a collection of information that's that collection is with structures. It's organized and it's controlled by a database management system most oftenly. And the most important aspect is that the system is mostly user active and system passive, and that means that the system is mostly controlled by a user inputting queries and waiting for a result immediately. Now, data streams, on the other hand, are user passive system active, and that means that basically the user inputs only one query at the beginning or several queries, and then they wait for outputs continuously. And that means that we can process data that comes from a continuous source or a stream at certain intervals. And this data must be processed on arrival, so that's the point of a data stream. Now, with this, there are several performance problems that we can see up there that are solved using operator scheduling. That's the main approach that also database uses. That basically means that you are trying to structure the operators in some way in order to reduce the amount of tuples that pass through different steps of the system. Also, benchmarking is used in order to measure the performance of a system, and that's also a point of research. And third one is load shedding, which is what we focus on today, and that's used, we'll see. So load shedding is a feature through which data streaming system can drop data in order to increase the performance of a system. That means that basically you are decreasing the accuracy of the system. So it's the downside of doing load shedding. But with this downside, you are getting better performances because the system doesn't have to process all the data. So that's the good part. This may be useful whenever you are using a very large system, basically very complex queries, or that has to process a lot of data, such as a website that may have millions of users at one time and very few users at other times. And the main research goes towards algorithms in order to compute this, in order to see how the tuples may be dropped. These are mainly random shedding, which means that you are basically flipping a coin whether you keep a tuple or not, or semantic load shedding, which makes use of certain characteristics in order to deduce importance, which is what we also focus on. And another one is scheduling, again. You can have scheduling specifically for load shedding, which means that you are basically planning where to put these shaders inside your system in order to increase the performance and also decrease the accuracy penalty that you're basically getting. Our proposals are to introduce two new algorithms, one that we call min-max, which makes use of minima and maxima, which we consider to be important characteristics. And when a tuple does not contain minima and maxima, then we fall back to random shedding. And the scope of this is to keep minimum and maximum values intact. This may be especially useful in critical scenarios, so when you have to focus on data that is minimal or maximal, such as in some, I don't know, reactor system. I don't know, if you have to measure the temperature, you would want to know when the temperature exceeds some threshold. And also a normal approach, which the name comes from the fact that we are using the normal distribution in order to compute if a row is important or not. And if not, again, we fall back to random implementation. Now, the implementation that we did is not inside of a data stream management system, it's inside of a continuous query executor. It's basically a small module that would go inside of a data stream. And we implemented these as operators, so you can put them wherever in your schema. As we can see, the min-max is implemented basically how you would expect. We find minima and maxima, and then we compare it with each row. And if the row contains minimal or maximal values, then we consider it important. Then we have the normal implementation, which computes mean and standard deviation for each row and for each column of that row. And then we update the statistic after each tuple is processed and use that in order to deduce the importance of a row using standard deviations. And then we also have a second normal implementation which does the same thing but in a different order. So we update the statistics only after the tuple is selected, some other differences. And also for both we use decay of the population in order to be able to accommodate for shifting trends. Now for the experiments, we have a simple query, as you can see. This is done in order to have an example with minimal amount of error and the maximum amount of data. This just streams some data, applies the drop, and then computes the aggregates, which for us are maximum and averages. As you can see from the results of this, mainly our implementations are doing better, except the min-max, which is doing worse on averages. And also it has a perfect score when computing maximum values, which is expected. Then for group by queries, we take two scenarios, one with a frequent class and one with an infrequent class. In here we can also see that the normal implementations are doing generally better, and min-max is again worse when computing averages, but again much better when computing maximal values. And for infrequent data, we can see the same trend, with min-max not having that much of an improvement when computing maximal data. That's because the data, there's not so much data in order to get that accuracy. And also join with column operation. This is done in order to use data from older windows, so to have something that's not from the current window. And also the operations are something extra. This generally does worse than random, or alternates between random and our implementations, with min-max again doing better when computing maximals. And for time performances, this is a very large schema. As you can see, this is in order to simulate the complexity of a large system. We do have an improvement, of course, when comparing to no load shedding. It ranges from 4 to 67%. And the overhead amounts to 18% when compared to random load shedding. And for conclusions, we consider that our solution is better when compared to load shedding, of course, and it's a better solution relative to random when accuracy is preferred. But we prefer also random shedding when we are constrained by the time performance, basically, because of the high overhead from our solution. So, thank you.
Any questions?
So if I understood correctly, if you compare a min-max approach and a normal approach, in the experiments that you perform, the normal approach is better.
Yes, it's better generally. When we only take a look on critical data, so on minimal and maximal values, then the min-max approach is better, but that's to be expected because it takes into account that kind of data.
So in conclusion, there are scenarios when one method is better.
Yes, yes. But generally, I think that normal should be the go-to solution when you want to have better accuracy overall.
Thank you.
Thank you.
Thank you as well.
Next speaker is
Andrea is here. Okay, then Alexandra Mika.
So, as you see from the schedule, there are no coffee breaks. However, there is coffee and refreshments if you need.
Alexandra, to ja ci-
Już chciałam sobie
Okay, thank you, Alexandra. Let's go.
Okay, so my name is Alexandra Mitya, and today I'll be presenting my paper about adding authentication, authorization, and accounting to a 64-bit operating system. First, since the introduction of multi-user personal computer, the need for protection from data protection became obvious. We implement that using the authentication of user, the division of them into groups, and the authorization check on objects that they want to access. So what I explored in this paper was presenting how user and data protection is achieved, describing the basic security components, and implementing them in the educational operating system used at my university. So we will follow the example of Windows, mainly the security reference monitor, which works in kernel mode and is in charge of user and group identification through security identifiers, access tokens, which hold the security credentials. Next, the object have security descriptors which hold their security information through the access control lists, which are used for the access check algorithm. I will be implementing this in the Harmony operating system, which is the 64-bit one used for educational purposes at the operating system design course. It works in a virtual machine, as you can see, specifically in room-aware workstation, and users can interact with it using the command line interface. So first, for the authentication part, we have the security identifier, which uniquely identifies users and groups. The image presents how the structure is for Windows, but we are interested in the number of the version of the security reference monitor, and the authority, which is a 32-bit randomly generated number that identifies users or groups. Next, the access token has the user security credential and is used in access check and logging operation. The structure, as you can see, is the user security identifier and a list of the security identifiers of the groups the user belongs to. For the authorization part, we have the access mask, which is a 32-bit value in which bits represent different access rights. The lower 16 one are object-specific access rights. So, for example, file read, when you want to read the file, is 1 bit of the 61, which can be 0 or 1. And the higher 4 ones, which are the generic rights, so each one is mapped to multiple object-specific access rights on the lower part. The security descriptor contains the security information of an object. It mainly has two lists, the discretionary and system access control lists. Each list has access control entries, which hold user or group security identifier, and an access mask, which holds the associated access rights of that user or group. So this is an example of an access control list on files. As we can see, if the process with owner A tries to write to file 1, in the discretionary list, we can see that it has the right to read and to write on the file, so it can perform that operation. But if it tries to write on file 2, then it only has the read access, so it won't be able to perform that operation. This is an example from Windows 8. So we see the file, which has a security descriptor with the discretionary and system access control lists. So here, for example, we have the user and an access mask associated with it. And here, if any operation that the user performs on an object, value specifically performs on an object will belong, because we have all the values of the access mask are 1. This is the state diagram of the access check algorithm. So when we try to determine if a user can perform an action on an object. We iterate through the object's discretionary access control list, and if the seed from an entry in the list has an ID, if the seed matches the one of the user or the user belongs to the group for which the entry is for, then the rights specified in that entry are deducted from the required rights for accessing that object. And in the end, we determine if the user is allowed or not to perform that operation, and based on the value of that, we iterate through the system access control list and see if we need to log the information or not. For the security accounting, we will log operations in the file system, in the specific file called system log, and the logging will take place when an access check is performed and the system access control is specified so, on administrator-specific actions, and on object creation. And we also have a setting for system-wide events logging, such as login or logout, which can be set by the administrator. So we used, for the password hash storing, we used the MD5 algorithm, which is a hashing algorithm to get a 128-bit fixed value. And these are the ways that we can improve the algorithm, but I used the basic approach for my project, since this was not a main part of it. And for the value of the security identifiers, I used the PUC32 random number generator. For the results, this is the table of the edit commands that I made for the project. So they mainly deal with the user management and the restriction and logging management. So, for one example, here we have the admin, which is an administrator, logged in, and it will add the user admin tray using the add user command, and then it will read the last 3 lines from the audit file, which are here. So we can see that it logged the action that was previously performed. Next, we log in as admin tray, and we try to read from the audit file as the previous user did. But since since admin tray is not part of the administrator group, it will throw an error because it's an admin-only command. If we log in back to the admin, it can add the user admin tray to the administrator group, which it does on the upper line there. Then we log back in as admin tray, and we can see that now we can read from the audit file, so it passed the check. So in conclusion, in this paper I explored concepts for data protection, such as security identifier, access token, access mask, security descriptors, and access control lists. And I implemented authentication, authorization, and accounting on HAL-NOMI, and presented the results of the implementation. And acknowledgements, and this is my bibliography. Any questions?
Thank you very much. So, questions, please. Which random number generator did you use? Some SCG32,
yes.
Which is what kind of generator?
It is a polynomial congregation generator, yes.
Okay, thank you. And you use this in let's say, educational operating system.
Yes.
That is used in the lab or in the course, even.
Yes.
What were the main challenges of your project?
Well, in the beginning, writing in C, because I wasn't used with dealing with pointers to pointers and structures, so that was pretty difficult, and it was a lot of work, so it took a lot of time. I had to write a lot of code for this, but yeah.
I mean, more conceptual or theoretical challenges.
Well, it took me a lot of time to understand how the access check algorithm actually performs and how it's tied together with the security descriptor, access control lists, and stuff like that, because everyone is pretty familiar with users and groups, but that part for the authorization was a bit more difficult, and how it all plays together.
Okay, thank you very much. Next.
Next speaker would be Marina.
Hello, so I am Maria Galan, and I will present the transfer learning approach for birth classification from images. This presentation will start with a short introduction in the topic, and then I will present the state-of-the-art approaches proposed by other authors for this problem. After that, I will move forward to the proposed solutions, and I will draw some conclusions in the end about the performed work. The birds play a very important role in the global ecosystems, as they have valuable contributions in seed dispersal, in controlling the agricultural pests, and even in pollination. And moreover, the bird watching is a popular hobby, as 45 million American bird watchers were counted by the US Fish and Wildlife Services. However, the extinction risk among the avian families is a serious threat that can reveal more matters of concern. So in this context, we aim to provide an intelligent classification system for accurately classifying various species of European birds from both high and average to low quality images. Here is a short overview of the state-of-the-art approaches. So, in general, the existing solution use images or audio recordings for this, but I focused on the images articles. So, in the first article, the authors use VGG16 as feature extractor, and then the output of this network is fed into a support vector machine or into a random forest. And the highest accuracy was 89% for the SVM. Then in the second approach, it is presented a multi-stage training as firstly the region of interest, namely the bird, is identified in the picture, and then the image is cropped and is actually classified with inception architecture. And the third approach presents a comparison between three pre-trained models applied to this problem. They use the birds 400 dataset, which will be the dataset also used in this paper. And the highest accuracy was 96% for the VGG16 model. Now our proposed solution uses two datasets. The first one is the birds 400 dataset from Kaggle. It contains data about 400 species of birds, and I filtered these categories such that we will remain with the categories that are now commonly found in Europe. The data was in general equally distributed. I mean, for each class we had 140, 150 images. And they were high quality images in which the bird occupy the most of the foreground. So to be able to identify the birds also in average to low quality images, another dataset was needed. So I took a subsample from iNaturalist dataset, and I created an automatic Python script to be able to select those 52 categories out of over 1,000. And then I filtered manually the images because there were some irrelevant ones, like images with feathers, with eggs, and so on. And we can see that in this figure that the data is not equally distributed. We can see that only 6 categories have a number of images greater than 150, and most of the categories have 95 to 1,110 images. So in this context, data augmentation was applied to generate 300 images per class. And in this picture, you can see a contrast between the birds 400 dataset and the iNaturalist dataset. And these images are more likely to be of interest in our context. Going further with the methods and the experiments, I created two models, one for each dataset. In the preliminary phase, I did some experiments with more pre-trained architectures, but I decided to go further with the Inception V3 as it generated the best results. For the model 1 was designed to be trained on BERT 400 dataset, and it contained the inception part and then a classification subnetwork formed by dense and dropout layers. The model 2 was designed for the iNaturalist dataset, and it is similar with the model 1, only that we used some activity regularization layers to prevent overfitting, as there was more augmented images. In the experiments, the model 1 was using Inception V3 initially as feature extractor, and then the model was fine-tuned by unfreezing the last 10 layers of the inception part. Similarly for model 2, but we ran it with the Inception V3 as feature extractor for 13 epochs. These are the results obtained the best results obtained for the experiment. Here we can see that the learning curves are similar and they follow an increasing trend for the accuracy and a decreasing trend for the loss. For the accuracy in the case of model 2 is significantly smaller because, as I said, there were various images and they were not so qualitative. In order to combine the advantages of these two models, a fusion approach was proposed. So each image is passed through the layers of model 1 and model 2 separately, and we extract the features from the dense 1 layer after the inception part. Then the output of these layers, the outputs are concatenated into a feature vector and then are further fed into an artificial neural network, for which more configurations were experimented, but I decided to use for the artificial neural network 3 dense layers and dropout layers and a layer with softmax activation in the end. Now, these are the best results obtained for this fusion model. It uses the Adam optimizer, the categorical cross-entropy loss, and I ran it for 14 epochs. Now, talking about our results, here are the results for Model 1 and Model 2. They were considered both in terms of smallest validation loss and highest validation accuracy, and we may observe that the fine-tuning phase increased significantly the accuracy in both cases, for the Model 1 with 3% and for the Model 2 with 6%. These are the results for the model that uses fusion data, and the results the accuracy is lower than the one obtained with Model 1, but this is a tricky result because, as I said, the Model 1 uses only qualitative images that were a little bit easier to classify. Now, in order to prove the efficiency of the fusion model, I tested all the models on a data set with 15 images per class. The images weren't unseen during the training or validation. And we can see that the results are improved significantly with about 9–10% for the fusion model. And in the end, we aim to compare our results with the ones obtained already in the literature, and we can see that our model performed better than the random forest, but a little bit lower than the support vector machine. And another comparison that is interesting to be done is between the article 5 that uses BERT 400 dataset and our model 1 on the same dataset. We can see that the accuracy is similar, but they use 200 classes, and in our case is 52. So maybe the BGG16 performed better on their situation. Now, as a conclusion, we focused our attention only on European birds, and the model using data fusion between the two datasets and the two models managed to obtain relevant results for the state of the art. And the main challenges were caused by the large variations of possible images because there could be different backgrounds, different positions of the birds, like flying or sitting into legs, and these images are quite different one with the other. And also a challenge that could be treated in the future is the differentiation between the male species and the female species, because there are some kind of birds in which the male and the female are very different. For the future work, we may enhance the data set in order to improve our accuracy and to better generalize the images. And this model could be integrated in bigger applications for monitoring the migratory tendencies of the birds. Thank you for your attention, and if you have any questions, I'm going to
Thank you very much, Maria.
Just when you compare to the class, can you go to the comparison slide, please?
This?
Yes. Why do you use only 52 classes instead of 200?
As I said, I was trying to focus more on the European birds, and indeed there were some birds that appeared rarely or accidentally in Europe, but I tried to focus on a smaller data set in order to do these experiments and to see how the models would perform with a smaller number of data, because I had also to filter the iNaturalist data set manually, and it would be a lot of work, and I wanted to do some preliminary experiments in order to see if this idea is okay and to continue with it.
If I may continue the follow-up, if you would have used the 200 classes, would your results have been better or worse?
I think that the accuracy would be smaller, because in general there are species that look very similar, and in my case there were only 3 pairs of species that could be confused one with the other more easily. And of course, if we increase the data set, the species that are similar could be more, and I would think that I would expect a decrease of accuracy.
Any other questions? Okay, very nice work. Maybe just a remark. For the future, if this subject is of interest for you, you might improve it with the wisdom of the crowd, with the expert opinion, allowing people to increase the data set and also annotate it. So this has potential, especially around metropolitan areas where birds are threatened. Okay. Thank you very much. And the next speaker is Corona Diana. Diana.
She's not here.
Okay. And
then we have Balázs Benedict. Also, don't forget because he has exited the room a few minutes ago, but I believe he will come back. So maybe we move to the next speaker.
then we move to Ashtigan Rajesh.
Yeah.
Are you ready to present?
Okay, no, like this, sorry.
But you are the next speaker, so maybe if you just go and prepare. Don't ask for.
It's not that difficult, is it?
Get stuff.
So, until he fixes out the technical stuff, another aspect, very important. You notice that during your presentations, there are some interruptions. Okay? So, or disturbances. Okay? You should be prepared for instance, her, when she had the interruptions, she stopped. Okay? No, stop. You are new in my life. Something, I don't know. Maybe I also know. Doesn't matter. Okay, so you don't stop. Doesn't matter. You don't assume that everybody in the room will be like this, watching your presentation. No. Some of them will be bored, some of them will drink coffee, some of them will go to bathroom, come back. Doesn't matter. You remain steady, focused on your presentation. You don't care what happens. You have a job to do. You do it the best you can, and be focused. Okay, so this is just another hint I give you for free today. Because I'm in a good mood. Okay, so Raj,
Just a second.
please.
Okay, hello, I'm Ashtin Arash. I'm a student at Faculty of Mathematics and Informatics at Babeș-Bolyai University, and today I'm going to talk about search engines, specifically how to build a search engine from scratch for a small part of the World Wide Web, and we'll also present an attempt of improving the relevance of the results with artificial intelligence, more exactly learning to rank models. So first of all, why do we need search engines? The problem is that the simplest answer, okay, so actually we need them because the simple answer is to explore the World Wide Web. The amount of information on the internet is constantly increasing, currently being more than 1.7 billion pages available. This meaning it is impossible for a person to look at each page until the required information is found. Search engines are the tools that facilitate this process. A search engine keeps an index of all web pages and offers the possibility to input a query and get relevant results back. Relevance is the key concept here. Out of this huge amount of information, filtering only the necessary information is a must. Google is the best example for this. Nowadays, Google, besides always filtering the most relevant documents out of billions, it even predicts the query that we are about to type. So the question is, why would someone try to build a search engine if Google already exists? So the motivation. From my technical point of view, the number one reason why I started to research into search engines and decided to build one is curiosity. I was fascinated how Google works and wanted to see what hides behind the surface, and indeed proved very quickly to be a challenging task. In a real-world scenario, a small search engine built for a specific domain or niche part of the web could offer increased accuracy and ability to implement extra features. So how do search engines work? And what do they consist of? All of them perform three basic tasks: crawling, indexing, and ranking. Crawling means traversing the web by recursively following links starting from a starting point. When a web crawler discovers a new web page via a link, it scans the content and submits it for further processing. Indexes are data structure that make it possible to quickly identify which crawled pages contain certain words or phrases. Once the bots have crawled the data, indexing begins, which is the process of evaluating and storing the material from the web pages in the search engine's index database. The final step is to select the best results and create a list of pages to be displayed on the results page. The quality of the results can be significantly improved by sorting the list of results using the relevant scoring function. Each search engine uses a variety of ranking signals, most of which are hidden from the public view. So these are the tools that I have used to build a search engine. Nudge is a complete open source web crawler that attempts to index the web as well as commercial search engines. Its flexible design allows communication to communities to personalize it, and it can even be scaled down to a personal computer, making it an attractive research platform for smaller groups. Solr is an open source enterprise search platform built on Apache Lucene, a popular Java-based open source library for information retrieval. Lucene is used for building and managing an inverted index. It creates an inverted index of the documents and adds it to Solr and searches it for matching documents when queried. Learning to rank is a Solr contribution model included in a standard distribution. It allows applying learned machine learning models to query results. The support vector machine rank algorithm is a learning retrieval function that uses pairwise ranking algorithms to adaptively rank results according to the relevance to a given search query. RankNet is a feedword neural network and one of the first generation of ranking algorithms developed by Microsoft Research Team. Next, the architecture of the UBB search engine. The so-called UBB search has the following architecture. Nudge collects data for the search engine by crawling the World Wide Web. Out of the gathered data, an index is built and sent to Solr, which is the core of the searching module. Solr also features the re-ranking module used to sort results by their relevance. Support vector machine rank and RankNet have been implemented and fed to Solr as trained models. After Solr has an index in which to look up data, a user can enter a query in the UBB search web app, which calls the Solr API to return the results for the query. Next, the collected data that I'm talking about. For this research, I have collected data with Nudge from both ubbcruj.ro domain and cs.ubbcruj.ro subdomain. Crawling starts from a seed list of entry points. For the computer science domain, I have built a list of about 192 URLs found on the top navigation bar of the website. After each URL is visited from the seed file, the links found to other pages will be used as entry points for the next crawling iteration and so on. For both cases, a crawling depth of 10 has been used, meaning that 10 crawling iterations have been performed for achieving this data. In this table, it can be observed that it is a very time-consuming process, which took about 15 hours for this one single domain and was limited to only 10 iterations. It can be observed that this document also occupies a lot of storage space in memory, 10.6 gigabytes for 55,000 documents and 710 megabytes for 6,000 documents. The index is significantly smaller, but still quite large, standing at 60 megabytes for computer science domain and 500 megabytes for the whole university domain. So this is the data I have collected for the UBB search engine, and this is the UBB search app, at least how it looks at first. It is a simple single-page application built with Vue.js, which offers the possibility to search, the possibility to choose from different re-ranking trained models, trained with the dataset built by me. It also offers the possibility to compare the results returned by these learn-to-rank models with the BM25 Solr original rankings and with Google search. In blue are the results returned by the learning-to-rank models, in yellow the BM25 rankings, and in orange the results returned by Google search for the same query. This is a convention that will be kept for the rest of the presentation. The results returned by Google have been obtained through the Google Custom Search API that is offered access to when setting up a Google programmable search engine. Next, the dataset for training. In the picture on the left side is the JSON containing the features I have added to Solr used to train and re-rank a document. On the right side is a snapshot of the dataset. An entry or a line in the dataset consists of the relevance score, ID of the query it was returned for, and the feature mentioned above and their values. A total of 172 queries and the corresponding results, 20 for each query, are present in the dataset. This makes a total of 3,403 entries for the dataset. For each single entry, I have manually assigned a relevancy score to mark from my point of view if this specific document is relevant or not for the query. Next, I trained the result with support vector machine and linear support vector classification. It was a real challenge to even make the support vector machine rank algorithm run for my dataset. In the end, somehow managed to successfully train the model, but the results were unfortunately disappointing. The model features a 90% error, meaning the accuracy of the model is then at 10%. Also tried with linear support vector classification, which is actually the same algorithm, but is part of the sklearn API. Similar results were obtained with linear support vector classification. The table on the right shows that the most relevant documents was among top 1 results in 65.5% of cases when ranked by BM25, and only in 6% cases were ranked by linear support vector classification. But although statistically the results look really disappointing, in real-world scenarios, these are queries for which the models return better results than BM25 original rankings. These results are even the same as the ones returned by Google, so an improvement was made after all. In this image, it can be observed that for query secretariat, in the mode is returned the contact page of the faculty, which is the expected result. Further, I trained the model with RunNet and tried to improve so I used the same dataset and used two slightly different RunNet architectures proposed and implemented by one GitHub user, Errolhorn, and Louis Kit-Law, a data scientist. The results of training this time are not bad. By the end of the training process, the loss has been significantly improved, as you can see in the graph. So, finally, here is depicted the comparison between the results for query secretariat and Burse. As we have already seen, support vector machine and RunNet provide better results, top one even same as Google for query secretariat, but for query Burse, this is not the same case anymore, for example. It does return web pages related to Burse, but not as relevant as before. This time, BM25 rankings return the same results as Google, at least the top one. So the conclusions of the work are that Natch and Solr are a very good stack for building a small search engine. The open source aspect of them also offers a lot of possibilities to customize the data used for the search engine. Another conclusion that can be highlighted is that maintaining a search engine requires a vast number of resources, time, storage, network, knowledge, and so on. And building a good search engine takes time, and because of that, Google Programmable Search Engine might be a better solution. It can be set up in less than 5 minutes and does the same great job as Google. Cost taken into consideration, in the long run, it might be cheaper to keep servers running and storage spaces if the search engine will be widely used, because Google charges $5 per 1,000 queries. And future work is to keep crawling for information, because this should be an ongoing process. The dataset needs improvements, maybe features which are not relevant should be removed, and collect feedback from users to add others. Later, Lambda rank could also be used to rerun results. And another improvement would be to add autocorrect, spell checker, suggestions, and even natural language processing to help the user with the query. That's it.
Any questions from the audience? No questions? Could you please go? I need clarification. If you could just go back on page 10.
Then? No feature. Okay.
Could you please explain again what is here? What are the results?
On the right side?
What's on the page? So
What's on the page? So,
just say it again.
okay, I didn't manage to actually successfully train support vector machine. I spent a lot of time even asking on Stack Overflow and something, no one could help me, and the articles are very limited to this algorithm. It's very old. And I finally managed to make it run, but the results were very disappointing. So statistically, they provide even worse results than the default original rankings. But when I actually use it in the real world, there are some queries for which it returns better results. I'm not really sure why statistically these results are very bad, but it proves to be a slightly improvement.
Okay, and then if you move to page 12, and just give us again a brief description.
Okay, so I used the ranking model. These are two very similar architectures proposed by two different persons that I use. I trained them with the data set that I built. This time on the graph it can be slight that the loss is decreasing in the training process, so which means it's an improvement, and the model is correctly trained. Yeah, that's it what I tried to expose here, I think.
And as a general conclusion, what you did? What would you say? General conclusion?
General conclusion?
Yeah.
That it's very time consuming to build a search engine, and it's even more time consuming and hard to improve the relevance of the results. Even taking into comparison that Google provides, as I said, the programmable search engine, which can be set up in less than 5 minutes. So the effort, I don't think is necessary to build a search engine.
Just as a remark, for your next presentation, I suggest that you put down your pages.
Yeah, I know.
And you do great without them. So
yeah, I know.
You just need them for
Yeah,
Yes,
really.
you get lost or even you keep this, but otherwise you do very good with that. Okay, thank you.
Thank you. So, Olash, so Olash, please.
I have to be connected to the internet because
No. No.
Asta e capul. Asta e capul. Nu, n-am dragere. Ieri mi s-a stricat laptopul și am pus SSD-ul și HDD-ul într-un alt laptop și n-am dragere. Sau, dacă poate să dea cineva un laptop, am chestii.
Pune pe laptopul ăla de pe
Da?
In the meantime, am și observat David, adică, eu știu că tu știi multe și tu vrei să transmiți multe. Are fenomenul de macro la butic, da? Și la comisie. Deci, pe comisie eu știi, tu o să vii probabil la ora mare, da?
Nu, scuze.
Eu o să
E posibil să duc
formatare. Eu mai pot să puteți înainte. Ea e mai zice, dacă dăm bacul nu se poate să deci se deconectează, deci lasă să zic.
E din cauza că știți că...
Da, așa,
n-am închis.
Nu știu dacă... n-am adăugărit aici. Ok? N-am adăugărit. Oh, e ok. Apasă pe asta. Asta? Da. Așa o să vin, dacă apesi pe aici, o să pe... Da, ok. Da, e ok.
La o comisie din aia de cealaltă, care la mine nu l-am gândat și la care o să-și și dea muncă. Okay, Balash, please start.
Okay, hello everyone, good morning. My name is...
10 minutes, please.
Okay. Hello everyone, my name is Balázs Benedek, and today I will talk about my license thesis with the title CAN-COMA, which is basically a shutdown attack on automotive electronic control unit over a controller area network. First of all, let's see the contents of my presentation. We will talk about the introduction, the design and implementation, the tests and results, and of course about the conclusions. First of all, let's see the overview of the subject. In this picture, we can see a simplified overview how network is placed in a modern car, and shutdown attacks can be a real concern for in-vehicle system, a stepping stone for more advanced attacks. And in this picture, we can see more suggestive photo how the system is placed in cars, in modern cars. The blue line is representing the bus, and some components are connected to this bus to share data, to transmit and receive information. For example, the driver monitoring system can send data to the dashboard ECU to say that, hello, please display that there is not enough pressure in the tire, to display on the dashboard that there is a problem. But, okay, what can happen if an attacker succeeds in intruding into the system? Attacker can take the control over the system, having only physical access to the onboard diagnostic port, which is used by the mechanics in order to see the tests, in order to see the problems which are encountered on the system, and by having this access, we can inject or modify existing data, but we cannot modify the hardware, we cannot cut the lines, because we want to remain unnoticed by this attack. Our goal is to use a software which can shut down a single issue, a single component from the system, because if we can control a single issue, we can have the total control over the system. For example, if we choose as a victim issue the dashboard issue, we can start the vehicle without the key, because the dashboard issue has the information for the ignition state. And let's talk about my proposed solution. First of all, our system is using this kind of standard CAM frame. This frame shows how the messages are sent on the bus. But the most important fields from this structure are the identifier, the ID, and the acknowledgement bit, which are used for attacking the system. Okay, and the hardware architecture of this work. As you can see, there are 3 issues. The green ones are simulating the communication in a vehicle, having, for example, the dashboard issue and the airbag issue. And in the middle, the red issue is the attacker, which is connected as well to the bus. And the architecture which is used in order to send and transmit receive data is sender-receiver. So if an ECU is sending the data, is appearing on the bus without being requested. And the other ECUs, if they want or they don't have a filter mechanism, they can read the data. So having the attacker, we can monitor all the data because we don't apply any filter. We can read all the messages that appear on the bus in order to see which are the messages with which IDs appear on the bus, and then to be able to attack the system by destroying a single message with this ID select to force the victim ECU to enter the shutdown mode. Here is an overview of the functionality. What can we see in this picture? The 2 channels in the bottom are representing the bus, because the bus is structured with 2 wires, CAN low and CAN high. And the rule for these 2 wires is to have always an opposite value on them, meaning that if the CAN high has a value 1, the CAN low must have 0 and inverse. And as the legend says, there are 2 ECUs, ECU 1 with a rectangle, ECU 2 with a circle, and the colors are distinct messages. In the first phase, in this part, we can see that there are 3 messages, 2 messages from the victim ECU, and 1 message from the other ECU which will remain safe. Then in the rectangle, in the red rectangle, we can see the intrusion itself. And we can see that the messages with the color green are destroyed when the acknowledgement is being happened, and the other messages are untouched. And after the intrusion succeeds, we can see that only 1 message remains on the bus. It is for validation of our system, because if we destroy a single message, the other message must disappear too, because the respective ECU entered in shutdown. So it is not transmitting any messages. Okay, but it is easy to say that we can attack these systems. And am I the first one who thought about it? No, of course not. So for this, there are some intrusion detection systems. First of all, in this list, there are some examples of intrusion detection systems which could be related to my work. And for instance, the intrusion detection software application, which is checking for the message periodicity, is not applicable at our work because we are not sending data. We are not modifying the periodicity. We are only sniffing those messages and then destroy them. So non-secure transceiver cannot detect this attack because we are not changing IDs that appear on the bus. We are only injecting malicious data when the acknowledged bit is being sent. So we don't put full frames. And the most the voltage intrusion detection would be the system could detect this attack, but as we include for a short time period, it cannot be observed because it cannot make a difference between this attack for this short time, or if it is some error in the system that it is normal, it is considered as a normal operation. And the conclusions, so shutdown attacks are a real concern to automotive industry. CanComa launches a physical attack by destroying the acknowledgement bit, and by destroying the acknowledgement bit and by this approach, we are targeting some individual frames from real issues, so we can force them into shutdown. And the last mentionable thing that I would say, that manufacturers must consider modern protections for these means of attack.
Thank you.
If there are any questions.
So, questions, please. Yes, please.
So,
Can you say a little bit louder?
Louder, of course. So, sorry if I missed it, but this CanComa attack, was it your discovery or?
Okay. There are some researchers who started to research about this topic, and the most similar project to this would be a Canon, which is using a shutdown attack on a single issue, but they are using a remote attack, and they are not destroying the acknowledgement bit. They are playing with the internal clock of the system to.
So in one word, it's original. It's an original attack.
As I know, yes.
Okay. As far as I know, it's an original.
Yeah, that was the question.
That was the question. And I'm presuming that you tested it in a simulator, not in a real car.
Not in a real car, of course.
Okay. Because it's very dangerous. Not
Yes.
for the car, for you.
Yes.
Because I know a situation when somebody almost killed somebody because playing with the can triggered the airbag. And the other guy was with the laptop in his face.
Yes, I know.
So,
I didn't receive in cars.
Very, very careful with this. Only in the simulation. Okay. Other questions? Okay. Thank you very much.
Thank you very much.
Next speaker is Dr. Christina.
If Coramo Daniela Diana did not come, she's not here. Okay. So we presume she is absent.
Right. Hello, my name is Dr. Christina, and today I'm going to speak about AI web application for nutrition. I start with the problem statement. Yes, nowadays technology is evolving at a remarkable speed. especially since a few years when the global pandemic hit. Due to the COVID restrictions, many people could not participate in daily activities like going to the gym or to cinema, which led to more time spent at home, and that led to the shedding of excess pounds. According to the World Population Review at the beginning of 2022, 36.2% of the US adults were overweight. On the other hand, due to the COVID lockdowns, the anxiety and depression increased. And according to a study in Ireland, more than a quarter of their population suffered from it. And it is well known that depression and anxiety cause malnutrition. The nutritional counseling is a science that deals with the physiological, biochemical, and allergological aspects. It gives advices on which food is right to eat, on healthy eating habits, which nutrients are good at what age. Of course, healthy diet and physical activity help achieve healthy weight and also maintaining, but their benefits go beyond weight. It is demonstrated that they reduce the risk of chronic disease, which leads to overall health and well-being. As a response to these mentioned issues, the nutrition web application was developed, but firstly, let's see what was needed. The Django web framework is a Python framework, but the main difference is contained in the fact that while skipgram uses a word input in order to predict the context for the given word input, the continuous bag of words uses the context words in order to predict the probability of target word being in that context. The neural network architecture of the word2vec can be seen in the picture. Word2vec uses a one-hot encoding of words that go to a projection layer in the hidden layer, and after that in the output layer. For the words to go through the hidden layer, it is used a weighted matrix with V rows and N columns, where V is the number of words in the vocabulary and N is the word dimensionality. Similar from the hidden layer to the output layer, it is used another weighted matrix, this time with N rows and V columns. And firstly, the weights are small random numbers, but then the error between the output and the target is calculated and backpropagated in order to update those weights. Now going further to the solution. The GISEH application was created, which is an acronym meaning Get in Shape, Eat Healthy. Here are the main functionalities of the application, but I will focus only on weight statistics and ingredient similarities because the time is short. As stated before, I used Django web framework in order to create it, and the project is divided into 3 submodules, namely Nutrition User and Forum. As their name already states, the nutrition module was used for the recipes management, the user for the accounts and the notification, and the forum for the posts, comments, and replies. The application allows 2 types of actors, the nutritionist and the simple user, and each user gets some body weight statistics, which were developed using the 2 formulas. One is for body mass index, and the other one is for body fat percentage. For creating the ingredient similarities was used the word2vec word embeddings, and it was used 2 data sets, one from Kaggle, which contained the recipes and respectively their ingredients, and another one from the Food and Nutrition database for dietary studies, which contained the ingredients, and for each ingredient its calories, protein, carbohydrate, fat, and sugar. As a result, the model not only predicts which ingredients are similar, it also gives insights about the nutritional values. As Word2Vec belongs to unsupervised learning, its methods of testing the performance are not that straightforward as for supervised learning. But here I put a table with the training performance on time. As expected, the bigger the data, the more time it is needed in order to train it. But it is also worth noting that if you train the model with the skipgram version, it takes longer time than with the continuous block of words. Yes, now some results. Here are some body weight statistics for a specific user, like weight fluctuation, what does the body mass index mean, and body fat percentage, and a range of healthy weight. Here are also some examples on ingredient similarities. You can search for ingredient similarities for a specific ingredient. And on the last column of the first picture, it can be seen the similarity percentage, and on the other columns, their nutritional value. But it can also test the similarity between two specific ingredients. Here in the picture, it can be seen bolognese sauce and Caesar salad dressing. As a conclusion, as the World Health Organization states, the obesity and malnutrition pose a significant threat to human health. And as a solution, GISEH is intended to help people eat more responsibly and become aware of their body weight condition.
Helping users how? They could, if they use your application, they could keep track of their body weight over time.
Yes, they will also get recipes from nutritionists.
Okay.
And if they are allergic, there are also the allergy statement there. They could search for similar ingredients.
Why would you search for similar ingredients?
In order to, if, for example, if you are allergic to nuts.
I see. To search for something which is equivalent, but you're not allergic.
Yes, yes.
Okay.
You said that you get advice from doctors. But this is from nutrition.
Yes.
Yeah, nutritionist, but this is not real time. You take it from some knowledge base. How do you get this advice? Do you have the actor?
Yes.
On your
Yes.
app? So this.
There are two actors, the nutritionist and the user, the simple user, and they can communicate through the phone. That's why it's
okay. Do you also take into account what the nutritionist is saying to the user in your algorithms, or
no,
just before?
Yes.
Okay. And could you go to the slide where you present that graph with corresponding to your method? More. Not this one, even
this one,
even before. I just wanted to ask you whether this Word2Vec takes into account in this library any entity is related to any entity. Could you obtain a score of 0 similarity between entity? Yeah.
Yes, it can be also 0 and also negative ones. If they're
okay. Okay. Because they're all of them are related.
Yes.
Right? Okay. Thank you very much.
Thank you.
So who's next? Ardelian? Ardelian or Fabian? Yes. And also Kuso, if you want to send suggestions. But please try to stick to the camera. Please stop.
Okay. So my name is Adrian.
Ignore everything that happens around. Just focus and stop.
Okay. So my name is Adrian Tavian, and this is my colleague Burzo Adrian. Today we present a visual simulator for variants of spiking neural key systems with inhibitory rods and rods on synapses.
Sounds interesting.
So as an introduction, we delve into the field of membrane computing, which is represent computing models that mimic the architectures of cells, making use of compartments called membranes. And more specifically, we focus on spiking neural key systems, which were introduced in 1998 by Georgi Paun, and which are a class of key systems inspired from the way neurons communicate by means of spikes. So we focus on neurons in interaction. Which is equivalent to computational power to Turing machines, main point about this, and it's able to solve anti-complete problems in polynomial time. And SNP systems are represented visually as directed graph and simulated through many text-based simulator or tables, which would be the main focus of our research and application. We want to develop a visual simulator based on common architecture for SNP systems with inhibitory rods and SNP systems with rods on synapses. So there are already simulators, as I said, many text-based, but also we found free visual simulators, but are all based on the original model developed by Georgi Paun. So these SNP systems with inhibitory rods and rods on synapses, which were developed in further research, they have no simulator as far as we know. So we wanted to develop such a simulator that is intuitive, modern. We use Node.js and Yarn as a package manager. We also have features such as step-by-step simulation. Also, we allow rule and node customization. It's very important for the user to choose the inputs and to choose how the simulation should be going and what is expected. And also provides a good open source foundation for future projects. To be noted, our project is already built on top of an already open source project. We'll get more into that. But before that, we want to see how we visualize our data. It's important to have a starting point, theoretically at least, for a simulator. So one such option could be these visualizations as a membrane containing another membrane. I don't know if you can see my cursor now, but it's okay, I'll try to explain it as is. So for example, how we simulate our data in this case, we have the most contained membrane, so membrane number 3. We have some input spikes, which are A and C, and we have 3 rods, called here rods. Now, the simulator is a non-deterministic approach, which means any rod can be applied. For example, this is just an example in the left-hand side. It could be not really infinite, but it could be a ton of combinations, let's say, for the simulator. So in this case, we have A, which is the first spike. That means A has 2 rules that can be applied. It could either fire and become AB, or it could be B and delta. Delta means that the cell is dissolved. In our first step, we can see that A is assigned to AB, so the first rule is applied, which means the second one will be ignored. And C has only one rule, C will always be transformed into a CC. So now at the second step, we have the input or the spikes A, B, C, C. Now A will be applied the second rule. Again, it's in a non-deterministic. In step 2, it will also have applied again the first so AB. So since A is assigned B delta, it will be dissolved at the next step, and C is again applied CC, and again CC 2 times. And so on at step 3, we can see that the cell is dissolved. We have the corresponding input and the corresponding rods. I won't go again over all these steps. I hope I was clear. But it was not our chosen approach. It was just something we experimented with. We went for visualization based on the state diagrams, which we feel are more intuitive to the common user or even experienced one. It's more easy to visualize. It allows to pause after each step and see very clearly where the rules apply on a synapse or what is in a neuron. Definitely low coupling, each neuron is independent and can be, is connected only by synapses, which, depending on the case to implement it, could have numerous values or properties, and also has increased readability when numerous cells are present, compared to the previous case where it could be a lot of cells just englobated one in another. It's very easier to see in this case. As starting point, as I said, we had 3 already present visual simulators, but again for the original SMP models. So one was a Python-based approach, which did not have a simulation per se. It had more an output of results on the choice history. Another one was Snaps, which was the first visual simulator implemented on these thematics. And another one is Web Snaps, which we used as our foundation. It's a web-based approach of Snaps. And as we can see from architecture, we have the web interface, which communicates with the controller, where we have neuron action, like adding, deleting, updating neurons, simulation settings, pausing, starting, going one step before, or going back to the current step, operation history, which we've seen the example presented, save file, and load file. These files, as we can, are optional, the output and input files. They represent the configuration setting, the preliminary configuration, all the rules present all the nodes and rules present on the graph, which can be easily exported and reused in other situations. And we have the model with the neurons, neuron state. Neuron state means the previous state of the neuron, useful for the simulation to go back and trace all the operations. The spikes present in each neuron, and the rules and the synapses. And I don't think it shows, but there is also the local cache there. I don't know why it doesn't show. And now moving on to the first type of class that we work on, there is spiking neural T systems with rules on synapses. This was first introduced by Song and Pan together with Georg Pohn, which is an SMP system, as the name suggests, that can be represented by a directed graph where neurons are placed in the nodes, and each neuron sends spikes to its neighbor neurons along the synapses. So as the initial configuration, we can see that we don't have any rules inside the neurons, but we have them on synapses. So it's very easy in understanding, but it changes all the rules of our implementation and our model approach. And now let's see just simulation step by step. Here we have the initial configuration. These are the N1 and N3 are the starting neurons, and 8 and 5 are the total number of spikes present in the neuron. So it means that N1, for example, will fire 8 times. And this on the synapse are the rules applied. So this means that it needs one spike to fire. If we fire one spike, and we have 0, for example, here is the delay. So this is the initial configuration. After we start the simulation, we can see that where each rule is applied. And we already see that from 7, there is this indication that these neuron fired. If one fire is deducted from the original total number of spikes. And we can see it fired from N2, N5. One is from N1, N1, and another spike is from N3. So we can see that here we have 2 and 2 spikes present in N2 and N5. Now, since we have spikes here in N2 and N5, that means that they can also fire accordingly to the output neurons. N4 and N5 and N6 being the output neurons. And this will continue until the simulation is finished, when no more neuron can fire anything. And the output is a spike train. So in this example, we have a bit comparator, and we just have the output in N4 and N6. Also, we have the choice history of each rule. But I won't get into any more detail. We can see which rule is applicable on any synapse and the output at each step.
Okay. Yes. Now the spike neural based system with inhibitory rules. There in this system we have two types of rules. Excitatory synapses and inhibitory synapses. Unlike excitatory synapses that increase the receptor neuron activity, the inhibitory ones reduce neuron activity due to a short circuit effect. Inhibitory rule is composed of an enable regular expression and an inhibitory regular expression, showing that the firing of such a rule depends on both the neuron state and the inhibitory neurons. Like the original model, spike neural pair system with inhibitory rules are also represented as a directed graph with inhibitory arcs instead of synapses. Okay, here we have an illustrative example. This example generates bits 0 and 1. Here we have 3 neurons, and neuron 1 and 2 have 2 spikes, and neuron 3 don't have spikes. Here we can see the rules.
Please don't go into too much detail. Just give us an idea. We cannot learn this formalism in 2 minutes anyway. So just give us the results.
Okay. The inhibitory rules is shown with an arc, with a circle, and firing rules is represented by arc with arrow. Okay, this is the initial configuration in our tool. The neurons with the rules. In step 1, the rule from this neuron was applied and generate a spike from neuron 1 to neuron 3, and in the same step, the inhibitory rule was applied from 1 to 2. Okay. In step 2, the same rule was applied. Another spike was sent to neuron 3. Now no inhibitory rules wasn't applied. So from the neuron 2 was generated a spike to neuron 3. Yes, step 3 is the same. The last spike was consumed for neuron 2 and goes to neuron 3. And also a spike was generated or consumed from neuron 3 to the environment. A step 4 and 5, the last spikes was sent to the environment. Yes, we have shows history where you can see the rules applied in every neuron and output. Okay, in the conclusion, this paper presents the first implementation of a visual simulator for spike neural pair system with inhibitory rules, respectively spike neural pair system with rules on synapses. The simulator gives user the possibility to design and modify their own system either by interacting with the web interface or by loading a predefined system. The main advantages is the easy of interaction that could encourage the user to deeply understand this type of systems. Yeah, future work, for example, we have variable-based rules which are essential in the implementation of more complex solution. And now the system is constrained by the number of spikes for a rule to be applied. For example, a to power k slash a goes to a, where k is the global variable that can be used in multiple rules definitions. And here we have some references.
Thank you. Thank you very much. So, before we have any questions, I would comment on your presentation. The problem with your presentation is that you are working with very abstract and unfamiliar concepts for us. I know the work of Jürgen Bohm in general in this domain. He's a legend in the field, of course, but the problem is the audience has no idea about this p-calculus that he invented, and the concepts are very difficult to grasp. You presented a lot of examples, trying to help us understand. We appreciate that. But I think you can do better. So in the next presentation, try to think from this point of view that, well, in a limited time, you have to make yourself understand or understood. And it's a challenge. It's a challenge because I believe that you are familiar with the formalism, but the audience is not. And from what I understood, you introduced this inhibitory rules in the already existing formalism or representation of the formalism, visual representation.
Yeah, visual representation.
So this is your contribution.
Yes.
So I would insist more on this contribution if I were you. But again, it's an opinion. So insist on your contribution. It's a challenge again. So this is the challenge. I hope you will succeed to overcome it. Anybody else? No question? No questions, so thank you.
Thank you.
Let's the next one.
What are the
Ce ne faceți mai de ea? Also, dacă poți să faci share, să scris articolul, să faci share la Zoom, la ecran, ca să se vadă, să transmită live. Am tras atenția că nu era făcut înainte, dar o facem. Gând ceva sau...
M-am gândit
Dar la licență o duci.
Așa. Se vede că
Hello, my name is Dora Maria Moraru and I'm going to present you the paper along with an application written under the guidance of Associate Dr. Adrian Sterca, which is entitled Automatic Music Transcription. There are many people who are interested in playing musical instruments. Even though the classical songs provide a good challenge and a learning experience, people might find it more interesting to play contemporary songs, especially new learners. The limitation is that most songs do not have a free public music sheet that can be used by everyone. We provide through this work a method of generating a transcription of a song in an automated manner. The problems we saw were three: note, tempo, and the time signature detection. For each of them, we dedicated a section where we present our solution. In the following, I'm going to present some musical structure concepts needed for implementing this application. Pitch basically defines how note sounds. The sound makes the air vibrate from the source to our ears. The number of vibration and the unit of time is called the frequency. The volume of the sound is given by the amplitude. When the sound vibrates in half, it produces a second harmonic. When it does, the third harmonic, and so on. The note is formed by many different pitches, which are called harmonics or overtones. The first pitch is the fundamental frequency and is the one that we hear. The next ones are the harmonics and are the multiples of the fundamental frequency. The tempo tells us how slow or fast a song should be performed. The beat is a unit of time which usually remains constant through the whole song, and the tempo is expressed in the number of beats per minute, but can be also expressed in words. A song is formed by many bars or measures, and the time signature is formed by a numerator and a denominator. The numerator tells us how many beats are in a bar, and the denominator tells us which note value should take the beat. Each note duration is divided from the whole note, and we divide the whole note by 2, we get a half note, by 4, we get the quarter note, and so on. In the following, I'm going to present the algorithms that we implemented in this application. The sound wave fluctuates a lot in a very short amount of time, hence it is very difficult to work with such data. When we read the data from the WAV file, we receive an array with positive and negative values because the local air pressure may be higher or lower than the ambient pressure. Therefore, we apply an absolute function element-wise in the array. Then we compute the root mean square function on frames of 512 samples. Then we compute the threshold because in this part of the process we aim to find the note intervals, and this means that we look for the higher amplitudes. We compute the threshold and look under it to find the intervals with lower amplitudes because these ones contain the unnecessary information for now. So these are the intervals that we receive. The red dot corresponds to the beginning of the interval and the green dot corresponds to the end. From this we can easily derive the note intervals. Even though there are some intervals that are below the threshold, they are not taken into consideration because they are too small. This minimum duration is 0.5 milliseconds. When we have a node interval, we aim to find the fundamental frequency of the node. For this, we convert the time domain into the frequency domain, and then we apply the Henning window and the Kaliturkey algorithm, which uses the fast Fourier transform. After this, we compute the threshold, which pulls down 99% of data, leaving us only the peaks. The idea we came for the algorithm of determining the fundamental frequency is the following. We take the first peak and consider it as the possible fundamental frequency. Then we compute the next possible harmonic of the fundamental frequency we have until now. Then we compute the range where the actual harmonic might be located. And then we start searching through the next peaks. If we found a peak which is in that acceptable interval, we have the new harmonic. After that, we recompute the fundamental frequency because now we have new information about it, namely the new harmonic. And we minimize the range where the next harmonic might be located because the idea is to get closer to the actual fundamental frequency. If no peak is found in the actual range, we go back and consider the next peaks as the possible fundamental frequency. The frequencies of nodes are situated on an equal temper scale, which can be computed using the formulas presented. The node which is correlated with the frequency that is closest to the fundamental frequency we previously found is the one that we consider. The frequency node intervals that we found contain essential information for finding the fundamental frequency but may not contain the entire length of the node. Hence, we compute another threshold below which all the silence and nodes should be located. For the tempo detection problem, we implemented two approaches, one with the discrete Wilder transform, which decomposes the problem into 5 steps. After applying all these formulas, a histogram is created by iterating over the signal and taking the first peak and its periodicity. The periodicity corresponding to the highest peak is the final tempo of the song. We also use the audio library, which gives us the position of the beats from the song, and computing the differences between two consecutive beats and the median over this, we have the final tempo of the song. For the time signature detection, we also implemented two approaches, one which uses the audio similarity matrix and one with machine learning. For the audio similarity matrix approach, we first define the numerator. This approach is based on the assumption that songs have a repetitive structure. Firstly, we compute the spectrogram, and then we compute the audio similarity matrix by computing the Euclidean distance between each two frames of the spectrogram. The important information is located on the diagonals which are parallel with the main diagonal, and we form non-overlapping groups of each bar length size, which is considered to be from 2 to 12. We compute the similarity measure for each bar using the formulas presented, SCSS, and for computing the similarity measure for a bar length, we compute the similarity measure equation. These ones are added to a histogram, and the value corresponding to the highest peak is considered to be our numerator. The denominator will be computed by rounding the numerator to the closest power of 2. Anacrusis is the phenomenon where the first node lengths of the bar do not form a whole bar. So, to check if we have the anacrusis or not, we shift all the audio similarity metrics and compute the estimation and check if we obtain a better SM. For the machine learning approach, we have the input, the audio file, and then the output is two sequences, the bits and the downbeats. The first part is the common for the both tasks, the backbone, which is an LSTM network. For this, we have 3 layers with 128 units, and this bidirectional, with a dropout of 20%. Then we have the upsampling layer because we have to have the unnecessary length. Then we have the heads. Both have in the end a sequence which two values each position, one with the score for having the bit or downbeat and one for not having it. During training, the network has to create the appropriate sequences of bits and downbeats which need to be as close as possible to the ground truth ones. In the picture, we have the max spectrogram, the bits and downbeats ground truth, and the bits and downbeats prediction. From here, we count how many bits are between two downbeats And the median over these counts will be the numerator of the time signature, and the denominator will be computed as in the audio similarity matrix approach. Here are the technologies we used and the evaluation. Here we test the node interval algorithm. We have one case where the actual number of nodes is smaller than the number of nodes subjected is smaller than the actual number of nodes because the length which is below the threshold between two nodes is too small to be taken into consideration, so the algorithm takes us as being only one. Here are the evaluation of the duration of the nodes and the fundamental frequency. We also computed the differences and the percentages, and if you look closer, the differences are quite small. Here for the tempo, where we compare the approaches, our tempo prediction with the Auger library, the TuneBack, which is its website, which also makes tempo prediction and the discrete wave delay transform, and also for the time signature with all the similarity matrix and machine learning, and for the analysis. I'm gonna show you first the actual application where we can upload a song, like this one. I'm gonna connect them. So you can hear, because we will receive in the front in the app music score, and then we can play it. So this is what we send. I'm gonna play it a bit so you can make an idea. Okay, and this is what we received. We can also have a cursor where we see which note is being played. In the conclusion, as music is not an exact science, it is more difficult to come up with a solution that has not one correct answer. Our future work proposes to solve these issues because our application can deal with simple songs with one note at a time, and the time signature algorithm works better when on repetitive songs. Thank you for your time.
I have a question. I noticed that you showed some tempo tables, and in those tables I noticed that the predicted tempo was like twice the amount of the actual tempo.
Yeah, but our wasn't, but there it was, but this was the wrong one. This is a problem because we do not have like some test that we can actually run, so I can prove it exactly to you that it was wrong. But if I play you the song and put a tempo on that value and on another value, I can prove it to you that is right. I'm going back to the slides. So
okay, but we believe you. We don't.
No, I wanted just to show. Yeah, Twinkle Twinkle is 60, and they predicted 120. You heard Twinkle Twinkle actually, so you heard that it was slow, and this means that it's slow. 120 is very fast.
Okay, but there are equivalents.
Yeah, it can be. I mean, we can put Twinkle Twinkle on the tempo 100, and then we have to change the note values and to make bigger ones. Yeah, that can be also possible.
Okay.
This is what I mean, because we don't have one answer. Yeah, anything can be possible.
Thank you.
Thank you.
Thank you.
Next speaker is Ron.
Da.
Nevoie să oprești.
Băiat, trage și răutau să colega.
Nu, să oprești.
Ce să oprește răutau. Ok, uite.
Yeah, my name is Larissa. I'm a student at the UBB, and I represent the theoretic side of my thesis. Now, I was present you a decision support system for prostate cancer stratification. Now, the presentation is segmented into 4 parts: the problem definition, why exactly do we study the subject, the state of the art, the current statement of knowledge addressing the subject, our approach, which sums up the data processing techniques I use, and the accuracy analysis, and then a conclusion, which includes a SWOT analysis and future work that we do. Now, the problem definition. Most of the time, patients with prostate abnormalities require surgery for examination and diagnosis. As a result, in the medical industry, a non-invasive way of correct and repeat processing of patient using only MRI data is required. Normally, even if we don't use the surgery, a medic has used many modalities in order to inspect the MRI. Now, a total of 33 patients were included in our study, 5 being reserved for placement purposes. Now, you can see here, I have the original MRI, the prostate segmentation, and the tumor segmentation. These were made by urologists from the General Hospital, so I didn't include them from my public data set. Yes, now our goals, I have a model analysis. We examined 3 architectures of 3 neural networks that have never been studied in the context of prostate and malignant tissue segmentation, despite the fact that they were designed specifically for the purpose of medical segmentation. Now, 2 of those were actually discussed in 2 papers, and one of them I modified one of the architecture which I'll talk about. Now, in segmentation, we use an artificial neural network to accurately locate and segment the prostate and the tumor. The main challenge we face is the precise classification of all pixels into 1 of 3 categories: background, tumor, and prostate. Now, the state of the art, many methods, artificial intelligence methods have been used. Now, CNNs, convolutional networks, give the best results, and now we don't have many patients to use, so CNNs have given the best results, so we use those. For specifically prostate cancer segmentation, 2 architectures were more interesting. You see, the one suggested by Yang et al., which uses as input data multiparametric MRIs, namely ABC and 2DW images. And the interesting thing is that they use image level labels that only say if there is prostate cancer or not in that image. And the architecture represents 2 concurrent DCNNs, one which is the ABC image, and one uses the 2DW image. And the bad thing at for this architecture is that they use MRIs and multiparametric MRIs, and you only want to use one, the normal 2DW image. And but the good thing is that they use image level labels, so we don't have a medic to segment each pixel in every MRI. And another is via Cadiral, which uses MRIs as input, and it's only a 2D CNN architecture. Now, the interesting thing is it incorporates 3D spatial information through a 2D multi-channel by moving a 3D window along the MRI data and taking some volumes of dimension X, Y, Y, I3. They extend the color size from gray level to RGB. X represents the height of the image, Y represents the width. The bad thing is, for this architecture, that it doesn't use all the volume, using only 3 slides, which doesn't necessarily give all the spatial information that we need for, say, a prostate cancer that covers 20 slides.
Now our approach, first we start by using the medical data preprocessing, and now the model creation and training, and then we test them and see the results. For data preprocessing, we first extract the region of interest, because we want to select only the most interesting part, and then we continue to data augmentation techniques. Now we use the rotated, and mirrored, which is just inverse, as you can see here, and elastically deformed, which was presented in a paper by Stemmer. And then we continue by data modification, resizing, so every MRI has the same shape, and for the computational data, and normalization using the SCP mean technique, and combining the mask using two categories. Data set after augmentation, we obtained a total of 140 volumes. For training, we used 112 of them, for validation 28, and testing 5. These 5 volumes were not augmented or anything, there's only them. Creation and training. Now, we have the dilated unit. The interesting thing is that it uses progressive dilation for every level. You can see the stride goes from 1 to 4 for every part in the encoder. The architecture is 3D unit, divided into main parts as usual for unit, encoder, and decoder. Learning rate is pi-4. Last function, category cross entropy, which is generally used for cross annotation. And for evaluation metric, we use dice for almost all of them. I forgot to mention in the training process, all of these are trained over 40 epochs and 32 steps per epoch. So all of these use the same, so we can value them. Yes, and creation and training of the UNet++ model, architecture is 3D UNet, as you can see. All of these are interconnected to bridge the semantic gap between the encoder and decoder to also give as much information as possible. Now, for the loss function, they use a mixed loss, which is a combination of binary cross entropy and dice loss as evaluation metric. And now, for the modified modifications, I saw that they use dice with a threshold of 1.5. Now, this cuts the training very fast if there aren't modifications good in the first five epochs, which doesn't give very good results. As activation function, I switched from prelude to prelude because prelude generally is medical simulation. And normalization function drop out to that normalization. And after every modification, especially with prelude, the parameters skyrocketed. So I had like 200 million parameters, so I wanted to cut from it. So instead of 2 convolutional layers for every bulk from here, I used 1 convolutional layer to cut a bit from the parameters. And as experiments, I want to see exactly how dataset affects the performance of every model. I trained each of them with 40 patients and another version with 28 patients. From the dilated units, these are the results. The dice remains from the medium of all these the 5 testing volumes. And we received the dice of 877, and for 20 patients, 0.868. Now, I think it gives a little bit less for the 28, maybe because the training is only on 40 epochs and we didn't have time to look to see distinct features in the other patients. And the UNet++, it didn't give very good results at first for 40 patients, and for 28, it was a little better, but not. The results are really contained and are very good, exactly. Now for the modified ones, the dice received the best of 0.88 for 14 patients, and the results are pretty good. And the train on 28 patients, 0.870. Yeah, the one for 14 gave the best result, 14 patients. Now, as I said, for training the original UNet++ model, it only trained for 10 epochs because it received very good results at first, and then it stopped improving very fast on 5 epochs. And the modified gives a gradient it gives better results. Yes. Now, as a SWOT analysis, our strength is we offer a fast and accurate way to study prostate cancer. As a weakness, we rely on pre-prostate data in which we extract the ROI. So we can apply this approach to any random MRI for any patients. Now, as a threat, this medical segmentation is an evolving research topic. New improved segmentation tools are being developed on a regular basis, which may leave our methodology lagging behind performance. And opportunities with thorough investigations and a larger database, the system can become a tool not only for segmentation, but also for diagnosing prostate cancer by also using an analysis texture afterwards or something like this. Now, for future work, it would be ideal for the region of interest to be able to generate it automatically without requiring the ground truth, perhaps by using a neural network that locates the prostate using a defined square, which for us would be 120 by 128 for each size of the body. Now, acknowledgement, the system was developed as part of an interdisciplinary research project between the and the Faculty of Physics, the Department of Biology, which they made the segmentations, and the Department of Radiology and Medical Imaging. Now, questions?
I was wondering, how do you compare what you did with the existing approaches?
The existing approaches mainly doesn't use MRI data, only uses MRI data, and I wanted to focus on that because that is what we generally have. We don't have a lot of modalities at hand for every. And now, in terms of performance, there surely are better ones out there, but since we only use MRI, I think it's very good. I didn't see one that only uses MRI, especially for prostate cancer simulation.
But did you have any feedback from the doctors?
Yes.
What do they say? That's important.
They thought that it's very good. They thought that it gives pretty good results.
Does it help them?
Now, I didn't publish that. They didn't use it since one was trained on 33 patients.
But you have a positive feedback.
Yes, I had received a positive feedback from them.
Do you have any suggestions from them as experts? Do they want something different, or is this a good direction?
They specifically requested this for prostate cancer. They had a larger database. Now, as with time, there will come on even more patients. So I think it would be useful.
Okay. Thank you.
Other questions? Questions? Well, we have a change of plans. I was just informed we have to move to another room. So please follow me. We will move to another building. That's okay.
Deci, în special cei care mai trebuie să prezentați, vă rog să veniți cu mine. Deocamdată...
Păi cum, și restul? Mai vedem niște lucruri?
Și restul, dar am spus, în special. Bun. Atunci să lăpesc.
General,
Da? Bă, nu, trebuie să ne anunțat că trebuie să ne mutăm în altă clădire, în altă sală. Bă, dacă spun, acum a venit doamna Mitra și m-a anunțat. Îl chid aici, nu? Din ăsta sau ce? Da, mă, că are decanul ceva. Nu știu, ăsta îl opresc, nu? Ăsta îl opresc, nu? Nu bine. Da. Nu? Nu bine. Atunci l-a deschis sala, bine? Deci vine el. Bun, atunci l-a deschis sala. Și nu merge în sala cealaltă. Am mai este, nu merge. I-a lăsat. Dă-te mesajele acum. Bine. Hai să lăsăm la noi. Nu știu dacă e la nu știu ce asta. Asta și eu, dacă pare. Să tot dispare, nu știu unde tot dispare. Asta că ai o posibilitate.
Stați că trebuie să intrați la monitor, bine? Și Dragan, lui aici al de dată. O dăm? Hai, să
And we go into the technical details with the cool dataset Food 101. It was introduced in 2014 by the Zurich Computer Vision Lab in Switzerland and contains over 100,000 images in the dataset. And the cool thing about this dataset, besides the fact that it has a lot of instances, it's balanced, meaning that for each category we have, each of the 101 category we have 1,000 images. 750 of which are used for training and 250 are used for testing. Now we go to the weaker partner, which is WEC 100. I hope it's pronounced right. It was introduced in 2012, and the reason I chose it is because it has support for multi-label learning, meaning for one image there are multiple labels. For example, there was a picture with burgers and fries, and we have for that picture labeled burgers and labeled fries, unlike the other data set. The reason why it's weaker than the previous pattern is because it contains only 14,000 images, which is like 10 times less than the previous one. So it makes it a slightly difficult learning process, and the way to obtain a good classifier that you generalize well are relatively small. Okay. I put that, yeah, this picture, I said that the cool thing about 211 was balance. This is relatively balanced. It has a slight imbalance with a few categories that spike up, but a general uniform distribution among the others. Now we proceed to talk about the algorithms. I like this picture because it's very suggestive to the way CNNs are used these days. Were used because they are used everywhere because of their results on ImageNet. So since AlexNet won in 2010 the ImageNet competition, there are countless models to choose from, CNN-based. We had VGG, Inception, ResNet, but the interesting ones that I like to include here are mobile nets, because they are, beside the performance that was taken into account when designing it, a latency, I don't know how it's called, parameter was there in order to penalize if the model was taking too long to output a prediction when training. So the reason I didn't choose mobile net because there is a slightly better model, efficient net, which there are 7 algorithms in this area where like the 7th is has the most parameters and the biggest and the best results. And I chose the 6th one because the difference between the 6th one and the 7th one is pretty small in terms of performance, but very large in terms of numbers of parameters because there are tens of millions. So I decided to go with this one. Yeah. We go from CNNs now to the vision transformers. We are published in 2021, I think officially, but we are known much longer than that, and are transformers-based models. Transformers have taken up the world of natural language processing, becoming the go-to solution in encoder-decoder problem. So, naturally, researchers have tried to integrate it in the world of computer vision. So, this way, vision transformers appeared, which in the notorious paper of an image is worth 16 by 16 words. And the idea behind it, because with the transformer we had words and we have to encode it. And for the image part, the idea is to split it into patches, whatever number it is, 14 by 14 or 16 by 16, and each patch is encoded several times into a number. And that number is like the encoding of a word. So we can say that that patch is similar to the, encoding of a word. That patch is similar to a word. And they have achieved state-of-the-art over commercial neural networks, which are the go-to solution until then. And these parameters, they are big models reaching parameters, they range from 85 to 300 million parameters. Big numbers. Before I talk about the results, I want to tell you how I evaluated the models. The first one is the cross entropy loss, which was used during training. We used two kinds of cross entropy loss. The first one was for the single label problem, which is here on the slide. I didn't include the other one because it's kind of similar with this one. Instead, with binary cross entropy, which has only two classes, while cross entropy may have multiple ones. And in the end, we evaluated the model in a more human-readable way using accuracy with the number of correct predictions, and we divided by the total number of predictions done by the model. Not so complicated. And now are the results of the experiment, which I didn't talk about, but I will talk now. The first one is the EfficientNet B6 with the transfer learning approach. This was like a first attempt, and the results, as you can see, are not so good because the number of learnable parameters was not big enough in order to obtain good results on bigger model, on big data sets like Food 101. As a disclaimer, by the way, these experiments were run on Kaggle and on a free account, so there were 12 hours of session. So you understand, I think, the numbers of 6, 8 epochs, it's rather small because of that. Okay, not having enough learnable parameters for the transfer learning, we switched to the fine-tuning. And for that, we obtained better results on the second experiment with having only on 6 epochs as starting point, we're having 97% training accuracy with 84 on validation, which was pretty good. But as the loss curve was pretty good and was promising, we decided to add 2 more epochs to another experiment, and we obtained better results, and this was the best result I obtained on EfficientNet B6. Now switching to the transformers experiments. The first one, I decided to not go with the transfer learning approach because I thought I would obtain the same results on the EfficientNet as in the EfficientNet experiment. So I skipped directly to the fine-tuning, where given 15 epochs, I obtained very good results on training, like 99-point-something%, I didn't include it, with an 82% validation accuracy. As you can see, this gap between training accuracy and the validation accuracy is a little big, so I decided to switch the vision transformer model to a B16, which is I think it has less than 2 million parameters less than the previous one. And we added 2 more epochs because, well, we could, the hardware resources allowed us. And as you can see, it was the best performance on the Food 101 data set with 99% training accuracy as in the previous experiment, but with an 89% validation accuracy. Switching to the WEC Food 100 problem, like multi-label prediction, we used the EfficientNet B6, and we let it train for 120 epochs. The data set was kind of low, and we could afford this kind of numbers for the training experiment. And the results were pretty good. I included just one experiment because as I ran multiple times, but playing with the architecture and the hyperparameters didn't help improve.
You included just one.
Yeah.
Okay. Keep it simple. Why included this?
Yeah. For the next one, I switched to transformers, and the results were pretty bad, like bad in the beginning. We were 33% on training and 40%. So we added 15 more epochs because again we could afford this, and we obtained better results on training accuracy, but a very bad result again on validation. So I'm not sure. I think the size of the data set has to do with this, and the L32 has like 300 million parameters, so probably that will result in such big overfitting. Now, if you compare with the literature review, we have the first one is a deception ResNet done by a fellow UBB student and obtained like 87% of validation. In the bold one, you can see it's this approach. I didn't include the best one, it's just mine. And other approaches like Deep Food, which is a custom CNN, again obtained good results, but transformers beat this. result. And if we go to the big ones with wiser and efficient at B7, we can see that we are close to wiser, but pretty far from the efficient at B7. As of the WEC, with the multi-label problem with 100, we beat the inception at ResNet done by Tudor, but and beat Food by a small margin, but we couldn't compete with Pfizer at all. Okay. As a conclusion, I think that vision transformers have a very good potential in the food recognition problem. And as a personal opinion, I think there might be a bug in the WEC 100 in multi-learning problems, so probably there's improvements in that code that could result in better results. And other future work include testing on a bigger data set, because there's the broader WEC 100, WEC 256 that has more instances and more classes. And this would be another point for the future. As well, it is worth trying to experiment with other transformers-based models, as there are now some that combine both CNN features and transformers to get the best of both worlds. Okay. Thank you for listening, and I hope I didn't bore you.
Any questions? Do you also have an application?
Yeah.
With your experiment?
Yeah, I have for my diploma thesis, I have a mobile application that does this, but I was told by the advisor not to include it here, and that's why I don't.
How are you using your results with the application? What are you?
I designed the application around the single label prediction, so I have the model that outputs the food class, and the user, which is a regular person, to take a snap of food, will send the data to the server, will receive the food class, and get back with nutritional values associated to that food.
Okay, and you do this with transformers, right?
Yeah.
Okay.
Yeah, the model behind me is not.
Thank you. Other questions? Okay. And the next speaker is Alexandra.
Hi everyone, my name is Alexandra, and today I will talk about SQL Cosmet detection. I will start with the definition, because it's important to mention that SQL Cosmets are not bugs. They can indicate the problem in the source code. I will talk a little bit about systematic literature review, and then I will talk about Cortex Smell Detector, the tool that I've implemented and validated with empirical study. Okay, there are three objectives that I wanted to achieve: detecting SQL code smelled by students and code refactoring, and then a tool to automatically detect SQL code smells that generate a report with those SQL code smells. First step in a systematic literature review process is to define keywords. We can see that I defined 4 keywords that I used to searching for databases. After all the articles that I found, I selected 10 that are in English, are fully available online, and the main subject is SQL code smells. Some of them talk about SQL code smells from student perspective regarding misconceptions, and some of them propose new tools to improve learning process. Okay, Cortex smell detector is a tool that I've implemented using SQL parser module from Python. It supports missing primary key SQL code smell. That means that in create table statement we don't mention primary key definition. And missing columns table in insert into statement. That means that you mention only table name without mentioning columns in which you want to insert data. And implicit columns in select statement means using asterisk sign instead of selecting only the columns we want to select at the moment of statement execution. Missing primary key, as I've already said, means not mentioning primary key in the create table statement. We can observe in the left picture that create table has only 3 fields without mentioning primary key. And in the right, we mention the primary key as a constraint, and then that means that the user is not allowed to add duplicate data in the database. And he is warned that, okay, there is another record with this data. To detect this code smell, I check the create table statement, and if primary key keyword is mentioned, I selected that column and added to a list. So if key list is empty, that means that there is SQL code smells primary key. Missing table columns means not mentioning table columns inserted into table. This can affect the programmer if he wants to add new attributes to a table later and execute the same SQL statement after adding a new column. We can observe that in the second example, insert into supplier ID, supplier name, we mentioned the table columns. To identify this SQL code smell, the statement, SQL statement, is to have an item of type identifier. If that means that only table name is mentioned, SQL parser module knows how to classify each element of SQL statement. If also columns are mentioned, this means that the third item of SQL statement contains the table columns. Implicit columns means that using asterisk sign, select all columns. This one was SQL code smell mentioned in an article that I found, but they used another method to detect this SQL code smell. So this means that the second item from SQL statement is an asterisk sign. We detect implicit column SQL code smell. To validate the proposed approach, I used an empirical study. The first step in this one was to create 2 datasets containing SQL statements and 2 forms that was filled in by 10 students from database program. And the last step, results and analysis. So I mentioned that I created 2 forms. First one was completed by 2 students and the other one by another group of 5 students. Each form was formed by 2 tests. First one was SQL code smell manual detection, meaning that each of the students received an SQL statements code and they had to find SQL code smells and then refactor them. The second test means refactoring SQL statements, but having the result generated by the tool. Here we can observe, more or less, we can observe that first dataset contains create table, insert table, and select statements. And in the right image, we can observe the result generated by the tool. So it's mentioned SQL code smell and statement where this one was found. One of the students who has to find the primary key SQL Postman mentioned that he was milked by alter table at primary key statement, so he didn't didn't succeed in finding primary key SQL Postman. The second data set is the same, but is applied on different tables. Here is the first part of the form. First section contains general statements about the participants, and the following three sections contains question about each SQL Postman. Did you identify this SQL Postman? How difficult was to identify? And how much time did you need to identify this SQL Postman? First group of students at section 4 had to perform code refactoring on SQL statements containing SQL Postman. And the second task was to perform code refactoring having provided the result generated by the tool. The last section contains question and statements regarding the participant experience. The second group of students had a new question because I mentioned that they had to perform first code refactoring and then they had to detect SQL code match without having the results. I asked them if they consider it was easier to perform SQL codes manual detection, having first an example. Okay, the results show that all participants had experience using SQL, but they don't have experience with detecting SQL code match. Yes, some of them mentioned that they don't consider implicit columns as code smell, but this can mean that they don't understand the concept or they consider it that it's fine to select all columns. We can observe that most of them found easy to detect each SQL code match, but however, not all of them identified them. There is an overview regarding the manual detection. We present the time and how students refactored the SQL statements, and the base analysis task is presenting the number of students who refactored the statements. In conclusion, results presented and the fact that students mentioned that it was easier for them to perform SQL codes manual detection after having an example. Context Math facilitates code refactoring for students. As a future work, I want to implement a plugin to support the programmers. This plugin will consist of mining repository algorithm and the SQL code extraction method. And maybe I will add some new SQL code to be more complex. This work was supported by a grant of the Ministry of Research, Innovation and Digitization, Tine Echipe Orchestra.
Any questions? I have a question. So, could you share with us your experience with this study? What was more difficult to do your side of the work, the implementation and the study, or the second part with the questionnaire and the students and the analysis? What do you find to be more?
For me, it was difficult to analyze the results and to try to understand what students, mean by saying, for me, it's not a code smell. It's fine to select all the columns, or it's fine to not mention the columns in selecting too. But In the same time, we at the university, I didn't hear about SQL Coachman, so I'm studying database. So it was something new for each of us.
Do you think it would be useful to propose something that would make them more aware of the importance of these aspects?
Yeah, because maybe we'll be programmers in the future, and I think it's relevant for time response, and it has benefits on programs that had complex structure and multiple data.
And how would you do this? How would you make them aware? By coding or by just instructing them on this end?
I think both of them are important. First, letting them know how they are and how they can affect the time response and the code, and then practice.
So next is Mr. Dishku, evaluation. So, nu știu citi. Hello everybody, I am Mihai Shishku. I'm going to talk about methods of detecting proxy malware execution. I'm going to so the outline, I'm going to go through this quickly. I'm going to talk about proxy execution of malware. I'm going to define it. I'm going to say why it is important, why it is a group of techniques used by malware, why we want to have more vision upon such techniques, and and following I talk about my proposed design and solution for the problem, and some tests, and then some hopefully interesting results. So everybody knows what malware are. You have heard of ransomware or spyware, stealers. A common flow of malware attacks, implies first you study the target, then you prepare your weapon, your payload. You then somehow infiltrate the target through emails or remote code execution or whatever. So there are many techniques for that. And then you follow up with, once you're inside, your objectives change. What you try to do is maintain persistence in evade detection by antimalware. One important group of techniques which malware use is called proxy execution, which can be simply defined as you have a legitimate trusted process or application, and then you have the malware, and the malware somehow manages to execute its payload or its functionality inside the trusted digitally signed process. These are some simple examples. The colors are that should be red. So there are many different types of proxy execution. I'm giving two examples to see what's happening. In the first example, you have a malware, I am malware.exe. You have a legitimate process, Teams, member of the Microsoft Teams software, and Teams has a vulnerability which, through which it can be tricked into loading a DLL, which is chosen by the malware and is malicious and ends up executing inside the legitimate process. Another similar scenario is you also have on Windows several methods for which are designed, so they are not bugs or vulnerabilities, they are designed to execute DLLs or execute different types of code. Malware can use that, and they often do, to actually simply execute in the context of a process which from the outside seems clean. So as we said, the recap for this part, malware use proxy execution for three main goals. Defensivation. When you look at the list of processes and you see teams.exe, you think that's okay. But that process might contain in itself malicious code. So that's in that way malware is hiding. You can have persistence. Persistence means in a similar way, if you try to clean up a malware infection, you might miss that that DLL was loaded by teams.exe and is still executing on the machine. And of course, privilege escalation. Those are classic attacks. You have an elevated process which loads a DLL planted by a non-elevated malware. The malware is executing as a low privileged user, and then it becomes executes as a high privileged user. Okay, so our objectives were to increase visibility on such scenarios because they're an important step to see what the malware does during an attack. Furthermore, we wanted to propose to implement something that is able not only to detect malware attacks, but also identify patterns in applications which might make them vulnerable to all these kinds of proxy execution attacks. Okay, we wanted to implement a system which runs on the Windows systems and generates real-time alerts both for malware attacks and vulnerable applications to these proxy execution scenarios. And in the end, this solution was integrated into a modern anti-malware software. Okay. Yes, so how we did it, we studied several such patterns. We proposed the architecture for the solution, and then we implemented it. The architecture is pretty simple. The Windows operating system offers many ways in which data about the running processes, the file operations, the registry operations. So the operating system offers this information. It is relatively easy to receive them. It is a bit harder to correlate them. So if you have a process creation, you have to associate it with all the DLLs it's loading or the file it writes in order to monitor this system. So we have such a driver component which collects this data, and this component then feeds higher level information like this process wrote that DLL, or this process created a new service on the system, and we have components which then analyze this high level information and can identify the patterns and generate alerts. This is the diagram, not very small, but what I said previously, you have a driver which receives data and then it feeds them to individual monitoring components. Each monitoring component is designed to detect one kind of proxy execution scenario. We proposed and implemented detections for that list of scenarios. I'm going to describe two of them. So we have hijack of escalation, hijack for escalation of privilege. As I said previously, that scenario when a malware writes a DLL which is loaded, which then tricks an elevated process into executing it. You have search order hijack. This is another very classical pattern in which is similar to DLL hijack, but is not necessarily for escalation of privilege. It's the same idea of tricking a process into loading a malicious DLL. You have misconfigured services, and in those services, a very important component of the operating system. Their configuration is stored in the registry, and it sometimes happens that those configurations are incorrect, or can be exploited, or they are improperly secured. And we have COM object hijack. I'm not going to talk about that. No, not really. That takes a lot of time. So COM objects is another very impactful framework in Windows. The effect is almost the same. You have a process which wants to use a DLL and is tricked into using a malicious DLL instead. Okay, so this is what I said previously, how elevation of privilege works. You have the attacker and you have the target, and these are the actions which we correlated in our monitoring plugin. If an unelevated process writes a DLL which is then loaded by an elevated process, it is likely that there is something wrong, because that is the generic pattern for privilege elevation. Okay. The second one I'm going to talk about service misconfiguration. As I said, services configured in the registry, they often run a system because they do important stuff in the system, so they are variable targets. The configuration for the services is stored in the registry, such as the actual binary path which is executed. That binary path might be bad, might be the file it targets might be writable by non-elevated processes, or it even may be missing. So an attacker might come in and replace that binary. Okay. So the monitor, that's what it checks. It checks new service creations. If there is something wrong with the path, it generates an alert. Okay. For the testing of these monitors, first we implemented synthetic tests. So no, we didn't write any malware. Synthetic test which performs strictly the action which is targeted by the monitoring component. So, for example, writing the DLL, editing the COM class registry configuration. And we also wrote scenarios in which we expect no alerts to be triggered, because it's actually not, the vulnerabilities actually don't exist in those test scenarios. Okay, for example, we have an elevated process which loads a DLL from a temp folder. That's bad, usually. We have an elevated process which loads a DLL from system 32. That's okay. That's what you should do, because system 32 is a system folder which has security configuration, so that unelevated users can't simply edit them, because that would be, of course, very bad. Misconfigured service, similar. the same idea. If it tries to execute something from temp, it's bad. If it's from system32, it's good. Of course, the actual checks are a bit more complex than that. So we look at the security descriptors of the folders, the elevation of the processes, the way in which the files are written. Okay. So that's kind of ends the part which ended in the article. Now, following on the implementation presented in the article, we present some real life results, because these implementations meanwhile ended up in market in a anti-malware product. We had in many hundreds of thousands of alerts. I'm going to quickly present one interesting finding we found. A case study for the Software Act. We're not going to give the name. Thousands of alerts. It seems to be exactly what we were searching for. It runs as a system user. It loads a DLL from the temp folder, which are usually writable. And when searching more about it, we discovered the single file.NET application publishing framework, which is a relatively new, it's about 2-3 years old technique, in which a .NET application is bundled as a single file, and when you execute it, it writes DLLs to temp and then loads them. If you, we found that we wrote a test application with that framework. We studied it. We found that this configuration of single file.NET framework contains a vulnerability where it attempts to load and execute kernel32.dll from that same temp folder in which it drops its own DLLs. So clearly there is a misconfiguration there, or an interaction between configurations in different components. An unallocated attacker can drop a DLL in that temp folder, and that is what we did to our own test application. And we have shown that in our test application in .NET single file framework, we have successfully shown that DLL hijacking for escalation of privilege is possible. And we have some photos with that, not really seeable, but we can see that we have managed to trick our .NET publish .exe, which runs a system. We have tricked it into loading that kernel32 DLL, which we planted as an unelevated attacker. So that's about it. Conclusions: we have shown, we have proposed and shown that these proxy execution detection and vulnerability detection algorithms they work by synthetic test and also by results in a model anti-malware solution. We have discovered at least one vulnerability, one potential vulnerability, what is very likely since we have managed to reproduce it with a test project. So we have discovered this vulnerability, and we expect to find many more by continuing to analyze the alerts from our monitoring components, which are being deployed in anti-malware solution. Any questions?
Questions, please? You mentioned something about digitally signed software model. I haven't seen anything about it. If it's digitally signed, then how could hacker insert?
Well, what happens is digitally signed, you have the executable, the main executable, which is digitally signed. When you execute a process, which you have in memory, you have address space, you have threads, whatever. You besides the main executable, which is digitally signed, you also load other dependencies, DLLs, other files. Those are so. What happens is the executable is digitally signed, but that guarantee of digitally signing does not translate into confidence that the process is secure or trusted. especially if the digitally signed application has vulnerabilities which lead to attackers tricking them into loading the errors. So the digitally signed part is the part where you trust the host.
Thank you for your other question.
Thank you very much.
Thank you. Diana.
Diana, Petra, is she here? Concha.
Okay, hello everybody. My name is Giovanni Concha, and today I'm here to talk with you about COUNTED, which is a system designed for yield estimation using the V5 model, which is trained with synthetical images. Okay, let's dive into it. And first of all, let's talk about the table of contents. First of all, I want to show you about something about my motivation and my objective with this paper. Then something about the related work, some problem statement, my approach, with my personal approach, and further work and further conclusions about it. Okay, let's dive into it. And first of all, I think that we can all agree that agriculture is a really important field, and it was really important since the beginning of humanity. And today we are gonna see a few aspects which made me approach this subject. First of all, the first aspect is an economical one, because as you know, in every field, in every domain, it's very important to get a profit from what are you doing. So in this case, our work aims to offer a good perspective on how things can develop in your farm, let's say, generally speaking, because everything is about profits or lose, and with this way you can see more about what you can expect from the future. This enables us to have a better strategy for the future, and this takes us to the second aspect, which is a strategical one, because we can offer an end-to-end application in order to be able to view the, let's say, statistic of the crop in your orchard. So as strategical aspect is very important, as it is the managerial one, because you can take into account few aspects like logistic or economical one, financial, because you can plan the storing of your crop, the selling of your crop, the future contracts that you can take. So the innovation is also important, because smart agriculture is a very developed field in recent years, and so it is our proposed work, because it's in the subdomain of precision agriculture. So as we said, the yield estimation is really important, but it is already done, by humans. The problem is that the labor shortage in agriculture is really present in recent years, and even it's in a good way done, it has some error prone. So our solution offers the use of method, because it is done faster, and we hope that it's more precise. So let's dive into some related work, because we have some state-of-art papers which are presented in this table. First of all, the most important one is the fruit counting based on deep simulated learning, which somehow has a similar approach, but it uses an inception ResNet trained on synthetic data with a result of 91% accuracy. Keep in mind that this number of 91% accuracy, because it helped us to get our metrics for the work we done. Next ones are somehow related too, because are using YOLO V4 and V5, but are using different data types for training, which are real videos or real images. Okay, and our problem statements, an exemplification of it, is somehow the end-to-end system that I was talking about earlier. It somehow allows the user to, the user which is a farmer in our way, in our case, upload the orchard image, which is transferred to the YOLO V5 model, which is doing the object detection. But our YOLO V5 is modified in that way that returns the number of apples present in that image. The results are saved in order to offer a good perspective and a larger aspect of that orchard or different sides of your orchard. So it saves the results for the user in order to be able to see that later and to compare results for, let's say, that specific orchard from different years. It also returns the processed image for the user and the number of fruits which will be saved in the database we use. As a personal approach, the most important actors, let's say, in our approach are the synthetic images, the YOLO V5 model, and the web application which enhances both of the previous two. Synthetic images are generated based on a Fruit 360 database, which is a really large database with different fruits and vegetables, but in our case, we only use the apples. We're gonna see in the few moments more details about how the images are generated and how are they used for the training the YOLO V5 model, which, as you probably know, is a single-shot detector, which has really good performance in our case, even though we talk about images or video processing. Okay, the web application is done as a web interface, which allows us to do the steps before presented before. Okay, more details about the dataset generation. A few details. We used 13 different classes of apples with approximately 2,000 images of apples, and allows us to generate annotations for that specific apples in the image. It assures randomness and diversification for our dataset, and in our case, the process was to generate 3,000 training images plus the 600 for the validation part. You can see in a slightly simple method the process done to generate the images. The image fruits are taken from the Fruit 360 dataset, are placed on the different backgrounds, which can be our choice. We choose how we distribute the backgrounds in order to simulate a better version of a real orchard. Sorry. As the result, the synthetic images is present there, but few things that are worthy to mention are that we can apply rescaling, cut out on fruits, and in our case, we had to modify this generator of synthetic images in order to normalize the output, since we are using the YOLO V5 model, and the annotations are a few different. As experiments, we started from the 13 classes of apples that we talked about earlier, but in the first really large experiment that we conducted, we only used only one class for detection in order to have better speed for our work. And first was done by transfer learning, because YOLO V5 offers a pre-trained model on the MS COCO dataset. The background modification and additions was done in few steps, because we had to add some sample negatives, like backgrounds without apples, in order to simulate a better view of a real orchard. The fine-tuning was done after, because we had to decrease the learning rate and to add some overlap in the synthetic images in order to be more precise on the simulation of a real orchard. The negative sample number was increased also. After that, we established that it's really important to do some validation on real images, which is somehow problematic in our case. But we used a formula presented in the Rachman-Fur paper that we talked about earlier. And as we see, we had to get the actual count from real images, from real orchard. And we compute the formula with the predicted count and the actual count from that images. It is somehow problematic because we weren't able to get enough data in order to validate this better, but we obtained a accuracy of 79%, which is somehow comparable to the results presented in the state-of-art part. But the number of real images is somehow problematic, as I said, and this takes us to the further work that is needed for this paper, which the first bullet is the validation on a larger number of real photos, which can be done in a few months in our case, because now it's not the real time, a good time to do it. The increased number of negative samples has to be done because, as you probably know, in a real orchard, there are few different things present. There are not only trees with apples in them, let's say, agricultural machines, humans, and stuff like that, and we have to enhance the number of backgrounds in order to simulate better this thing. And as well as a promising thing, we think that the real-time object detection can be done, and it can offer better results than the detection from only images. As some conclusion, it is important to mention that synthetic images have a great potential that can be used, and they are giving us easier way to annotate and generate data sets for different types of things. And as proposed, our proposed method can offer reliability in order that we can use it for different type of crops. Let's say we can choose another type of fruit or vegetable in order to train YOLO-V5 and make the detection and counting of that. So smart agriculture can improve, and I really hope that I convinced you that it's not enough tackled in our days, and it is really important to take it into account because it offers us food and it has to be fast, and this fast aspect can offer us lower prices, let's say. So thank you for your time, and if you have any questions, I will be pleased to answer them. Thank you.
Questions. Nice work.
Thank you.
I just wanted to know whether you have spoken with some experts from the domain, some agriculture.
I am an expert.
Do you have their opinion, their requirements, or have you studied them? How is this in line with the reality, let's say? Because, okay, it's very nice what you did, and one can really see the point of your work, but are you in touch with the guys who are really there on the field?
I spoke with a few, only a couple of them, but it is somehow relatable because myself, I was growing in a slightly sorry, I can't find my words right now. In a similar way, I was grown and born in the countryside, and I was really enhanced in this type of work. And I spoke with some people. I do need some more validation from real farmers which do this as a full-time job, let's say, not like a hobby or some people that has this thing in their garden. But I'm in the process of contacting some people near Cluj-Napoca, which can help me in the next part, which is the validation of real images, because I would like to take some real photos in that situation. And of course, if they allow me to do this, I will present my work also to be able to validate more their opinion, let's say.
Okay, thank you and good luck.
I have some questions too. For first I thought it takes the pictures from the air with a drone or something.
No.
So you take the pictures yourself.
Yeah.
You walk through the
orchard, yeah. And let's say you take a full row and take picture of each one of them, but it's somehow problematic, and I take this into account that apples are present in both sides of the tree, and you have to be careful that some of them can be present in both sides of the photos. Let's say if the tree is here, you can take photo from here and here, and some apples can be present.
That's what I meant when I said have you spoken to some, because it is important to, let's say, take images from the same site every year to make a comparison, or it doesn't matter, or how,
Yeah, it's
which
somehow
are the best
important.
angles. So these are requirements from the, I think, from the field specialists.
And it's somehow important to have some more validation and to make it, let's say, more accurate.
Okay, thank you so much.
We still have some time, so let's talk. Why is this so important? What do you? I was under the impression that this is not the most important question people in the field have. How many apples do I have this year? This is the question you are trying to answer.
Yeah. Well, let's say.
Let's say you know how many apples.
Yeah.
You know apples are big, are small, are medium. What's that? I think you are interested in how many kilos of apples do you have.
Yeah.
How do you make this transition from how many apples do I have to how many tons or kilos of apples do I have?
Only for the quality of the fruit from the image.
Of course.
Yeah. There are a few aspects that have to be taken into account in the future, but there are a few papers that offer would, let's say, besides the detection and counting of them, they use some formula, mathematical formula, in order to weight some of the apples, and with that formula, they extract the predicted weight of all the apples. So with this taken into account, it is really important in order to be able to store all of the apples. And let's say you are a farmer which has an orchard, and let's say you can contact bigger retail supermarket, let's say, but when you have to make the papers, the contract, you have to be able to provide the estimated number of kilos or something like that to them in order to be able to deliver them when it's required. So if you don't have a view on how
what happens if you underestimate or if you overestimate when you sign the contract?
Well,
because I know. So,
well, this is a problem, but this is a problem in nowadays too, because as I said, it is error prone when it's done by humans, because we are humans and we can mistake, and it's not a really easy job to do it in a real orchard. So somehow is a better way to do it digital, because it can provide better results.
No, I don't agree. It's better to do it digital now. This is an illusion, the illusion of technology. I take the oldest guy in your village, I take him into the orchard, and he will give me an estimate which is 10 times better than yours.
Yeah, but
do you agree with me?
Yeah,
If
I
not,
agree with
please
you. I agree with you, because I know this type
So
of people.
humans are better than machines.
Yeah,
Let's clarify this.
There is a problem too, because younger people are not really interested in going into orchard. As I know, because in my village everybody's leaving and nobody has to do it.
Okay.
And we have to provide some replacement for that old people that they don't have to teach. They don't have anybody to teach that aspect, that experience.
It's very good, very good. So we don't have, when we don't have people, we use technology.
Yes.
I agree with that. Okay, very interesting topic. As you can see, a lot of discussion.
Yeah, it's a good way to promote this and make it better, let's say.
No more questions.
Okay.
Thank you very much.
Thank you. So I was, no, let's switch to Romanian. Stop the Zoom transmission, please. You can stop this. We ended our session. I was informed that the final session will be here in our room. So let's just wait. I think we are the first ones who finished. So please enjoy some food or something from here. In the meantime, until the others come here, because iar am zis că vorbesc Deci aici o să fie specificitate, așa am înțeles?
De la ora 2, nu?
Da, la ora 2.
În principiu, da. Să vedem cum vin și ceilalți.
Deci noi suntem deja la locația potrivită.
Exact. Deci avantajul este că ne-am mutat la locul potrivit.
Yes.
A fost o mișcare. Ziceți, domnul, cu ce vă putem lua? Luați, vă rog, o măslină, o oră, nu știu ce avem aici, o alună, un pahar de suc, dacă doriți. Ce ne spuneți interesant? Eu? Ceva, da. Interesant. Asta de pe lângă. Asta n-a fi indicat. Acum sper că au trecut emoțiile.
Da, au venit ca banii să merge. Au venit să vă vedem până în ultimul pe aici.
Da. Păi nu, ca să se discut foarte și eu primesc separat. Și deci să dau unei premii pentru cei care
Deja de aia e diferența în lista de la UPP apare și căutare.
Sunteți în același responsabil.
Ce am văzut,
nu știu, asta poate fi o misiune din asta.
O misiune.
Am încheiat cu succes. Toată lumea care a fost prezent a susținut. Putem opri teoretic astea.
Dar nu mergea la de la noi și am terminat cu să
S-a terminat. Bine. Ok. Hai să îl oprim. Ăsta dumneavoastră. Cred că puteți să-și luați. Eu nu mai trebuie. Dacă mai e ceva. Nu, de aici trebuia să îl opresc.
Aia, stație așa.
Îl opresc?
Da.